So question 7 says we have 7.1. How many years will it take an investment to double in value if it earns interest at a rate of 8.5% per annum compounded quarterly? Okay, so it's compounded quarterly and this is your interest rate. So this type of question, it has been showing up quite a lot in various papers. So this is how we're going to work through this. Remember, this interest, this investment, it is being invested and then it doubles at the end of the period. So it means that it's going to grow. And you can already see that we have compounded quarterly. So this is the compound interest growth formula we'll be using, which is A is equal to P bracket 1 plus I raised to the power of N. Okay, so you can also just go ahead and look for that formula in the formula sheet just to make sure. So all we have to do here is we're going to have to find out what A, P, and I is going to be. Remember they say how many years, okay? So we are actually looking for this N. So how many years is it going to take? Okay, let's go ahead and put down everything we have. They say that, so this is what we're supposed to get at the end, the accumulated amount. They say that an investment, they don't tell us the amount. So what we can do is we can assign an amount to this investment, to the principal amount. Let's say the investment was 50 Rand. So since this investment needs to double in value, the accumulated amount would be 100 Rand. This would work. And then let's go ahead and find the I. The interest is 8.5%. which you can put as 8.5 since its percent is over 100, and that would give you 0.085. But remember they said it's compounded quarterly, so you need to say over 4. Okay, so that is that yearly interest being split into quarters. Then for the N, you see the N on its own just represents the amount of years, because remember in these financial math questions, when they tell you something about money was invested for 3 years, for example, and they say compounded monthly, you would usually take that 3 and you multiply it by 12. So what I see that 3 as is the years is the N. So I'm going to take N and say times 4 since it's compounded quarterly. And so this gives us 4N. Now 4N is going to represent your quarters, okay, not your years. It's just going to be quarters. Then we are going to convert this quarters into years by dividing both sides by 4. Okay, so let's start substituting. So the first value we have is A, which is 100, is equal to, the principal amount is 51 plus, and then the interest is this 0.085 over 4 raised to the power of 4n, and all we're just trying to do is solve for n. Okay, so to solve for n, since this is an exponent, what we can do is get rid of the number in front of this. Okay, so the 50. So we can go ahead and get rid of this. Since it's been multiplied, we will divide both sides of the equation by 50. And then 100 divided by 50, that is just going to give you 2. Is equal to, this 50 cancels, and you have 1 plus 0.085 over 4, all raised to the power of 4n. Okay, and now that we have this, you see that we actually need to get to that 4n. What I like to do is simplify this. This can actually be a fraction. So on your calculator, you can find out what 1 plus 0.085 over 4 is going to give you. And you see, I'm going to leave it as a fraction, not a decimal, because I don't want to round off. So that we just have 2 is equal to, and then this as a fraction is 817 over 800 raised to the power of 4n. Okay, so remember, we're just trying to solve for n. So we need to make that 4n the subject. And the only way to make an exponent a subject is by using log. So clearly here, they're just really trying to test your use of log. So we're going to make 4n the subject is equal to, and we're going to have to say log, and we'll have the base here. The base is just whatever number was carrying the exponent. So that is 817 over 800. And then, of course, here we will have the 2, whatever your exponential equation was equal to. So we can go ahead and put this into the calculator. Remember, you're going to use this log, not this one, the one with the base. So we're saying 817 over 800. And then come out of that, and inside this bracket, we're going to put the 2. So, okay, I'm just going to press SD. My calculator is doing that. So this is what we have. So we have 4n is equal to 32.9640, and this keeps going. Then we need to solve for n, the years. So this is the amount of quarters. So divide both sides by 4, and let's see what we get now. N is equal to, so I'm going to take this and just say divided by 4. So it's divided by 4. And when we divide by 4, we get 8 point, and if you round up to 2 decimals, 24. And I'm going to leave it like this, years, because technically this is still in years. I haven't converted it into any other thing. Okay, and that's our answer for this. So now we can move on to the next question. Okay, so now we have 7.2, and 7.2 says a company purchased machinery for 500,000 Rand. So this is how much they purchased it for, the starting amount. And after 5 years, the machinery was sold for 180,000 Rand, and a new machinery was bought. Okay, so this is how much they started off with the machinery with. That's how much it was. And they ended up selling it for this amount. So you can see it's depreciating. The first question we have is calculate the rate of depreciation of the old machinery over the 5 years using the reducing balance method. So it is a depreciation going, but using reducing balance. When they say reducing balance, this refers to compound decay or depreciation. Okay, and that formula just looks like this. A is equal to P bracket 1 minus I raised to the power of n. So you see it's still compound interest, but it's decaying this time. So in this case, your principal amount will be the money that you started off with. How much did the machinery cost at first? It costs first when they purchased it, it was 500,000 Rand. So that would be P, 500,000 Rand. And then they said that after 5 years, it was sold for this. So you see it lost value, it depreciated, meaning this is now your accumulated amount. Okay, it's not really accumulated because it actually just decreased, but this is what they ended up selling it for. This is now what it's worth. So that would be the A value. That's what we end off with. So this is really the starting amount, the ending amount. So that is 180,000 Rand. And then we have 1 minus, what is the interest? Well, it seems like they're asking us for the interest. They said calculate the rate of depreciation. Okay, so we don't know that rate, it's just I. And also notice they don't really say it's compounded monthly or quarterly or anyhow really. It's just compound interest. So this is being compounded on a yearly basis. Then we're going to raise it to the power of the amount of years, which is 5 years. So here we're just solving for I. Okay, so how do we solve for I here? We're going to have to look at the fact that I is inside here, and in order to get to I, you first have to get rid of this 500,000 so that we can get closer to that. So the 500,000, we can get rid of it by dividing both hand sides by 500,000, and let's see what we get over here. Okay, so when we divide that 180 divided by that, we get 0.36. I'll leave it as a decimal because that's a nice simple decimal. Is equal to, that cancels, and now we have the 1 minus I raised to the power of 5. And now in order to get to this I, you see we have to get rid of the 5. So this is an exponent of 5. The only way we can get rid of it is by fifth rooting both sides. So we're saying the fifth root of that and fifth root of that, because it's an equation. What you don't on one side, you must on the other side. Now, something that you can do, it's not really necessary in this question because we have such a simple decimal. But sometimes you could have a decimal that looks more complicated or a fraction that is really big. You know, that button ans is going to be very helpful. So when we calculated this, it recorded the answer in that button. So even if you just press AC and you say the fifth root of ans, you'll get that answer. Okay, but that fifth root, we really just get it by saying, we're going to have to say shift and that. Okay, so then we'll put 5 there and we'll fifth root in 0.36. Okay, this is what we get. So we get 0. And this can't be a fraction, right? Nope. So 0.81519, and this keeps going, and this is equal to, this now breaks open and we have 1 minus I. Okay, notice that I is negative. Something we can do is take this negative I over instead, and now it becomes a positive I. And then we still have the 1 on the right hand side, and we can take this 0.81 over. So it becomes a negative 0.81519, and it keeps going. So let's find out what 1 minus this is going to be. Okay, and I noticed I was supposed to say 81519. Okay, so I is going to be equal to, you can just say on your calculator, 1 minus, and if you say ants, it's going to take whatever number was there. Okay, so 1 minus ants, that was the last recorded answer. So we're going to say I is finally equal to 0.18480, and this keeps going. But then to make it a percentage, you're going to multiply this decimal by 100. And so it means that your interest is actually just going to be, so I'm going to take that and multiply it by 100, and it is 18.48, and just rounded as 2 decimals percent. Okay, so that is the interest that we're going to have. Okay, moving on to the next question. Then the next question, 7.2.2, says the rate of inflation for the cost of the new machinery is 6.3% per annum over the 5 years. What will the new machinery cost at the end of 5 years? Okay, so the rate of inflation, whenever they're speaking about inflation, inflation causes prices to increase. So we're going to be using the growth formula. And when they're referring to inflation, it's going to be compound growth. Okay, so that's how inflation works. Then we know the rate of inflation. Since this is the formula, A is equal to P bracket 1 plus I raised to the power of N, that's compound growth. Let's just figure out what these letters are going to be. So if we know that this money, whatever we're investing, is going to grow, the fact that they're asking us what will the new machinery cost at the end of 5 years. So the new machinery, meaning after this money has grown, it means that we're looking for A. So what is the principal amount we are investing? Well, they're telling us about the rate of inflation for the cost of the new machinery. So what was the old machinery that we had, or really just the present machinery? The current machine that they have was the machine they purchased for 500,000 Rand. Okay, this is the current one. This is going to grow in future. Okay, so it's probably a specific type of machine, and they have to buy that specific type of machine. But in 5 years' time, it's not going to cost 500,000 Rand again because of inflation. So that is our principal amount, the current machine they have. So 500,000 Rand, that is going to grow in 5 years. Then the interest is 6.3% per annum. Okay, as you can see, it's not compounded anyhow, it's just per annum. So that is going to be 6.3 over 100, which will really just give you 0.063 as our interest. And our N is 5 years, that's what they're telling us. So let's go ahead and just substitute this in. So we're looking for A, the principal amount is the 500,000 Rand, and 1 plus, and then we have the interest, 0.063 raised to the power of 5. And you can just put this into the calculator. Let's see what we get. And we get 678,635.11 cents. That's how much the new machine is going to cost in 5 years' time. Okay, moving on to the next question. Okay, so question 7.2.3 says, the company set up a sinking fund, okay, and made the first payment into the fund on the day the old machinery was bought. Then the last payment was made 3 months before the new machinery was purchased at the end of 5 years. The interest earned on the sinking fund was 10.5% per annum, compounded monthly, and the money from the sinking fund and the 180,000 Rand from the sale of the old machinery was used to pay for the new machinery. Okay, so because they're speaking about a sinking funds, we use future value because this is a savings plan where you're going to be paying a consistent amount of money every month so that you can be able to buy something new, in this case, a new machinery. So remember, the future value formula looks like this. Okay, and at the end, they say calculate the monthly payment. So the monthly payment would be the value of X. That is your monthly payment or your consistent payments, whether it was compounded monthly, quarterly, yearly. So that would be those consistent payments. In this case, it's monthly. So we're looking for X, and let's go ahead and find everything else. We can first of all find the future value. So how much do they actually need to save up? Well, remember, they had this specific machine. So they bought this specific machine. So I don't know what type of machine it is, but they bought this machine for 500,000 Rand. And this machine, it is going to depreciate over 5 years, the one that they have. And they also have to buy a brand new machine. So when you want to calculate that future value, we're just going to say the accumulated amount, the one that appreciated, the new amount for the machinery. So how much will it cost in 5 years minus the old amounts, the amounts they sold the current machine they have for, minus the old machine. So that would be the new machine, the one that was increased because of inflation. That amount was this. Where we took the 500,000 Rand, which is the current machine they have, and we went to go ahead and grow it using the compound formula. So that we're going to take that amount first, and then we're going to subtract that by the old machine. Now, what did they tell us about the old machine? In this question, the first question, they told us that this machine is going to be sold for 180,000 Rand. That is their current machine that has depreciated in 5 years' time. So you see, they're not throwing the machine away after 5 years. They're going to sell it for this amount and use this money to contribute towards buying the new machine. So minus 180,000 Rand. That's what we're going to first of all put by the future value. So let's see what that gives us. So that gives us 498,635 Rand and 11 cents. Okay, so this is how much they need to save. Okay, so we know the future value, and let's figure out the other easy things first. The second thing we can also just put down is the interest. So it is compounded monthly, and this is the interest. So the interest is just going to be as a decimal. That is going to be, you can just put it as 10.25 over 100 and then put it in decimal form. That will be 0.1025. But this is compounded monthly, so divided by 12. Okay, that's what we have there. Now let's figure out what N is going to be. Let's just see what they're saying here. So they said that the company set up a sinking fund and made the first payment into the fund on the day the old machinery was bought. You have to think about it like this. When is the company actually supposed to make this first payment normally? So if this was just a normal situation where they were saving up money to buy a new machine, the thing about this is you set up the fund at a specific date. I'll call that T0. This is where the fund is set up. Then naturally you're supposed to start putting money into this fund 1 month after the day the sinking fund is set up, because this is an account really. And so where the sinking fund is set up, you're supposed to start 1 month after. But if you look at what they did, they didn't start 1 month after. They started putting money into this sinking fund on the day the old machinery was bought. So on the day they bought this machinery, which was worth 500,000 Rand. So it means that they actually started this payment immediately. They started it at T0 instead of T1. So you can see a sinking fund like this. On the day that they bought the old machinery, that was the day they were just supposed to set up the sinking fund. They weren't supposed to put money into it. Then 1 month after, they were supposed to start depositing money. So you see, a sinking fund is really just a plan to really just maintain a machine that you have. So you buy a machine and then you set up an account for that machine. They calculate how much it's going to depreciate, and then they also calculate the price of a brand new one. And then they start saving money into this account and they deposit their first amount 1 month after, but they didn't. They started immediately. So this is how we're going to have to look at it. How long were they going to be depositing money into this account? Remember that this whole thing, right? This whole sinking fund is for 5 years. Okay. So it's going to be for 5 years. So let's see, since this is compounded monthly, let's see how much months that's going to be. If we are saying 5 years and it's compounded monthly, we're going to have to find out this by saying times 12 to find out how much months this will be. This is a total of 60 months, meaning naturally they're supposed to make 60 payments. But the thing is that they started this payment immediately. So that's actually a way of them telling you they started immediately instead of 1 month after. So since they started the payment immediately, we're going to say plus 1 extra month, meaning now they are on 61 payments instead of the 60. Okay, let's continue reading. Then they say the last payment was made 3 months before the new machinery was purchased. You see, with these payments, they're supposed to end at T60 naturally, right? This N is equal to 61 is just because they are paying exactly at T0 immediately the fund was set up. So they're supposed to naturally stop at T60, but now they're saying that they actually stopped 3 months before the new machinery was purchased, the brand new machinery, not this current machinery that they have. So that will be the machinery they are saving for. So imagine they stopped paying 3 months before this. Okay, this is where they were supposed to end. This is really where they were supposed to buy the new machine, but they stopped paying 3 months before this. So 3 months before T60 or month 60, you would have to just say 60 minus 3, right? And 60 minus 3 is 57. So this is at T57. So it means that at T57, this is where they make the last payment. So let's calculate how much payments this is going to be. So from T1 to T57, we can agree that that is 57 payments. But remember, they're also making a payment at T0. So in total, the amount of payments that they are making into this account is 58 payments. So we can erase all of this. Now we know there are 58 payments being made. Okay, so long what we have is we have the value of X, we have the interest, we have N, and we also have I. Of course, that is the interest. So let's put this down so long. We're saying that the future value is equal to, we have X, open bracket 1 plus I raised to the power of N, and then minus 1 over I. Okay, well, so let's just see. The thing about this is this account, okay, is actually going to last for exactly 5 years. And exactly 5 years, okay, is 60 months. Because if you times that by 12, that is 60 months. The last payment will be made at T57. So if the last payment is made at T57, what happens to the remaining money that is in this account? Because remember, this machine is only going to be bought 3 months after, because they said that the last payment was made 3 months before the new machinery was purchased at the end of 5 years. So this new machine, it's still going to be purchased here at the end of 5 years, meaning at T60. So what happens to all that money that they have been saving? Well, that money is going to grow. Everything is going to grow and gain interest for how many months extra? Since we stopped at T57, that was the last month they deposited money in. And so it means that since it's going to grow from T57 to T60, how much months is it sitting in the account? It is sitting in the account for 3 months extra. So it's going to grow for 3 months. So this is what we have to include here. We have to say multiply by 1 plus I raised to the power of the 3 months. Okay, the 1 plus I is really just so that whatever the future value amount is, it's going to multiply to the 1, okay, and become its number. Then it's going to also multiply to the I so that that full amount can gain interest with 3 months. Okay, so this one is not one of those simple types, really. It's really not one of those simple types. We can go ahead and calculate this now by saying the future value that we have. We already calculated the future value by saying the new amount, the appreciated one minus the depreciated one, and it gave us that. That's the future value. So that's 498 and then 635.11 is equal to X is what we are looking for. We don't have that yet. So X, open bracket, then we have brackets 1 plus the interest is 0.1025 over 12 raised to the power of n, and n in this case, okay, so the amount of installments made, that is 58 installments are made. So we have to the power of 58 minus 1, close bracket, over, then we have 0.1025 over 12. And now this needs to grow for 3 months extra. Okay, so multiply by 1 plus your interest is 0.1025 over 12 raised to the power of 3 months. This is the calculation, and we have to solve for x. Okay, lots of big numbers. What we can do is simplify all these big numbers. You see, all of this is being divided by this. Then, as this number is as a fraction, I'm saying this top over this denominator, it's being multiplied by all of this. So we can put everything here onto the calculator like this. So first I'm going to create a fraction for this part. So I'm saying fraction. Then on that numerator, I'm going to, I don't really need, well, I can put this big bracket first. So big bracket, then a new bracket for that small one. Then we can say 1 plus 0.1025 over 12. So over 12, come out of it and then close that bracket. And we're going to raise it to the power of 58. The power of 58, then come out of that. And we're going to say minus 1, close the bracket. Then over is going to be over this. So that is 0.1025 over 12. So that's this part over here. And then I'm going to take that. I'm coming out of this. And I'm going to multiply that by this little part here. By the bracket 1 plus 0.1025 over 12. And then come out of that and close the bracket and raise that to the power of 3. Okay, so just make sure you check everything. Everything is fine. And then this is what we have. We have the x being multiplied by all of this. You see, because this is a fraction on its own and it's being multiplied by that part. So really we calculate all of that. So we have the x and then bracket 76.590978, and then this keeps going, is equal to, of course, this number over here. Okay, so this is where that ans button is very, very important. You see, as we have calculated this answer is recorded in that ans button. So what I'm going to do is I'm going to go ahead and we need to solve for x. To solve for x, we need to get rid of this. So we'll divide both sides by the 76.590 keeps going. So I didn't round off yet. Divide by 76.590 and it keeps going. So I'm saying that x is equal to, so x equals all of this 498,635.11 divided by this 76.590. But remember, this answer is recorded on your calculator as ans. So you can say divided by ans. You could press AC and then put this amount, this 498, all of that, and say over ans. It will actually find the answer because it recorded this number in that ans button. My calculator works a bit differently. I have to say equal to first, and then I'm going to say the 498,635.11, and then I'm going to say over ans. And there we go. So this is the amount we get. So when you divide it by that, we get that x is equal to, so of course you will show them that you said 76.590 and it keeps going. But then you can just use that button ans instead. So we're going to say it is equal to 6,510 rand 0.37 cents. That is the amount they need to invest monthly in order to achieve this, in order to be able to buy a new machine in 5 years' time. Okay, so that is it for financial maths for this paper. Hey grade 12s, and welcome to this video. In this video, we're going to be working on question 6 of Gauteng's 2022 paper 1 June exam. So the first question, 6.1 says, for how long must 50,000 Rand be invested so that it can double at an interest rate of 8.5% on a straight line method? Give your answer in years and months. So they're asking how much must this amount be invested so that it can double. So it is growing. So we're going to use a growth formula. And then they give us the rates, and also they say on a straight line method. So this is not compound growth. This is simple interest growth. And so the simple interest growth formula looks like this. It's A is equal to P multiplied by 1 plus I multiplied by N. Okay, so it's not raised to the power of N, it's multiplied by N. And now, because they say how long must 50,000 be invested, the money that is invested is your principal amount. So that is our principal amount. So in place of P, we're going to put the 50,000 Rand. And then they also tell us the interest. They tell us that it's 8.5% per annum on straight line method. So we're going to have 1 plus, so 8.5% as a percentage is going to be, of course, 8.5 over 100. And so that will give you 0,085. So I'm saying plus 0,085. And the question is saying for how long. So since it's for how long, we're actually trying to find N. So N is missing, so we can say times N. And so we see that we actually need the value of A. So notice they say for how long must 50,000 Rand be invested so that it can double. So the amount that you get after these specific years that this 50,000 Rand is growing is going to be double of whatever you invested. So double of 50,000 would be 100,000. And so that is your value of A. So 100,000. And so all we have to do is just solve for N. Okay, in order to solve for N, you see that in this bracket, we have 1 plus, then the 0,085 is being multiplied by N. So in order to get into the N, we first have to get rid of what is creating this bracket, and that will be the 50,000. So since the 50,000 is being multiplied by the bracket, to get rid of it, you would divide both sides of the equation by 50,000 Rand. And so if we say 100,000 divided by 50,000, remember 100,000 is double of 50,000. So that would just give you a 2. And then we have is equal to, the 50,000s would cancel here. And now the bracket is open. We have 1 plus 0,085 times N, which just give you 0,085 N. So we're still looking for N. On this side of the equation, you can see that we have two terms. Terms are always separated by plus and minus signs. So here's a plus sign. So this is your first term, second term. We need to take the 1 over so that we can get that alone. So we have 2 minus 1, which is just 1, is equal to 0,085 N. And then in order to solve for N, we will just divide both sides of the equation by 0,085. And we can go ahead and put that onto the calculator and see what we get. So you see, we get 11, so N is equal to 11,7647, and this keeps going. But then they tell us that we need to give our answers in years and months. Okay, so right now the N would represent years because this is not being compounded monthly. We didn't divide the interest into months because it's on straight line methods. So the N is telling you the amount of years. So first of all, you can start by taking the whole number that you have. You know that it's definitely 11 years already. So we have the 11 years separately. Then we still have these decimals. We still have the 0, so you can remove 11 from this number. So if we just say minus 11, and so we see, okay, we have this 0.764705, and this keeps going. So we have to find out. This is in years right now because everything here is in years. But instead of leaving it like this, we need to put it in months. So think about how we convert something from years to months. If 1 year is equal to 12 months, then it must mean that if you have something in years, you just have to multiply it by 12 and then it will be in months because 1 times 12 is 12. So we're going to take this decimal as it is. We're going to take the 0,764 years, and we're going to multiply it by 12 so that we can get the months. I'm taking this answer, the 0 point, this that I have, and I'm going to multiply that by 12. When I multiply by 12, you can see that we get 9.1764, and that keeps going. So that means that's 9 months and 0.1764 months as well. That is still all in months. But now you have to think about it like this. We are saying that this money gets invested and then it's going to double after a specific amount of years and months. In 9 months, exactly 9 months, the money would not have doubled yet because we still have the 0.1764. So instead of saying 9 months, round it up to 10 months, because in 10 months, you would definitely have 100,000. You actually have more than 100,000. So that's why we're going to round it up to 10 months, because when we round it up to 10 months, we know we're at least going to have 100,000. Even if we have a bit over that amount, we will have 100,000 instead of less than 100,000. So this would be 11 years, n is actually equal to 11 years and 10 months. So this is how you always have to consider these things, even in future value and present value. You have to think about, by this time, will I have that amount that they're asking for, or will I have less than it? Okay, and you need to always have either that amount or at least more than it. Okay, so that is it for this question, and then we move on to the next question. Okay, so question 6.2 says, a cell phone valued at 24,000 Rand depreciates at 18% per annum on the reducing balance method. Determine the value of the cell phone after 3 years. So because it's depreciating, we're going to use a depreciation formula, but they specifically say reducing balance, and reducing balance is always going to be compound depreciation, and that formula looks like this. So this is the formula for compound depreciation. As you can see, it looks like the compound growth formula, but instead we have a minus so that the interest can be taken out of this money. And now to figure out what is A and what is P, we're going to look at the fact that they said a cell phone valued at this depreciates. So the money that depreciates, that is going to be your principal amount, because what is happening is that this money is going to get smaller. It's the starting value. It's where we are starting off. We started off at 24,000 Rand, and then this money is going to depreciate. So of course that is our value of P. Then we also have the interest rate. They tell us it's at 18% per annum, but also notice they don't say compounded monthly or quarterly, it's just per annum. So that is going to be our interest. And then they also tell us that it has to be after 3 years. What is the value of the cell phone after 3 years? And that is, of course, our N value. So we can go ahead and just substitute all of those in their correct places. But when we're talking about the interest, you also have to just convert that into decimals, or you can put it as a fraction, but it's easier as a decimal. So it's 18% per annum. So since it's in percent, it's 18 over 100. And just put that as a decimal. That is just 0,18. So we're just saying the 24,000 and then multiply by 1 minus 0.18 raised to the power of just 3 years. This is not compounded anyhow. And so the A amounts that we're going to get, put this onto the calculator, and we finally get our accumulated amount or depreciated amount as 13,232 Rand and 83 cents, rounded off to 2 decimals because it's money. Okay, so now moving on to the last question in this financial maths section. So our next question is 6.3, and we have X Rand is invested into an account at an interest rate of 12% per annum compounded monthly. 3 years later, 2X Rand is deposited into the same account. After 7 years, there is this amount in the account. Determine how much money was invested at the beginning, that is the value of X. So whenever they start mentioning things like this, they tell you a certain amount was invested into an account. And then they start saying 3 years later, another amount was invested. You should already know this is timelines. So this is a timeline that we're going to be working with. Okay, so X Rand is first invested. Then 3 years later, this amount is invested. And then they're also telling us that after 7 years, we know how much is in the account. So let's draw a timeline. As you can see, the last years that they mentioned, they said after 7 years, this is the total amount in the account. So because it's after 7 years, it means that this timeline is only running for 7 years. So this is how we can actually draw the timeline. We're going to start at year 1. And I like to call it terms and not really years, because sometimes they're not really referring to years. Sometimes they're referring to months. Sometimes it's quarters. So I'm just going to call it terms. And this timeline is running for 7 years. So we're going to end at term 7. And the reason I start at term 0 is because no years have passed yet. I cannot say 1 full year has passed. This is just when the person opens this account. So what happens in the beginning? They tell us that X Rand is invested into an account. So that's what goes in term 0. We have X Rand coming into this account. And it's being invested at an interest rate of 12% per annum compounded monthly. So we know what the interest is as well. The interest is 12%, which as a decimal, 12 over 100 is 0.12. But it's compounded monthly as well. So we have to say over 12. So we can divide that interest into months. So then they say 3 years later, 2x Rand is deposited into the same account. So we're seeing it as this is the first time the person puts money into the account. No years has passed yet. Then 3 years later, so it's going to be 3 years later since we're at year 0. It's year 1, year 2, year 3. So at term 3, new money gets invested into this account and the money is 2x. So putting 2x into this account now. And then they also tell us that after 7 years, there is this amount. So after the 7 years, at year 7, at the end of year 7, we have this amount, 276,558 Rand and 75 cents. That's how much we have in the account after 7 years. So the question is for you to determine how much money was invested at the beginning. Okay, because these are just investments being made, you're expecting the money to grow. So we're going to actually use, and it's compounded monthly. So we're going to use the compound interest formula. We're really just using this formula. A is equal to P bracket 1 plus I raised to the power of N. So when we're putting this in, we have the principal amount. The first amount we have is X. X is being invested. So we're saying X, open bracket, then we have 1 plus the interest rate for the whole period is this, because they never said that the interest changed at any point. So we still have the 0.12 all over 12. And then now, when you have to raise it to an exponent, this is where you have to think about how long was this money in the account. Because X Rand was put at T0, it means that this is how long it stayed. It stayed from T0 all the way till the end. It stayed till T7. So we're going to have to raise this to the power of 7. But remember, this is compounded monthly. So we need to turn that 7 years into months by saying times 12. Okay, so that is the end of the X. We have now inputted the X and also inputted how long it has stayed in this account at this interest rate. Then we move on to the next deposit that we have, which is this 2x. So 2x came in at term 3. So then we're going to have to say plus, because it came in at term 3, plus 2x. And we open a bracket and then we have 1 plus, again at the same interest rate, so 0.12 all over 12 raised to the power of. And now you have to think about how long did this money, 2x, stay in this account? It only stayed from term 3 all the way to term 7. So counting at term 3, term 4, 5, 6, 7, that is 4 years that it stayed in the account. Another way of looking at that, you could have just said T7. 7 minus 3, that's 4. So it stayed only in the account for 4 years. And again, because it's compounded monthly, we have to say times 12. And as you can see, no other money was invested or deposited into this account. But then at the end, at T7, the total amount in this account, or the accumulated amount, is this money. And that's what we're going to put in place of A. So let me just move this a bit more to the right. And so this money is going to be in place of A. This is what all of this is equal to. And this is what we have so long. So we just need to solve for X. So before moving forward, I would just like to simplify a few things like this. 1 plus 0.12 over 12. That can be put as a single fraction. I can also just put that as a single number, and this as well. So we still have that accumulated amount is equal to, and then we have the X, and then this inside the bracket is going to become, so all of this is just going to become this simple decimal. Now, sometimes the decimal looks more complicated than this. In that case, you can put it as a fraction. But because this decimal looks simple, I'm just going to take it like this. So that's just a 1.01 raised to the power of 7 times 12. So 7 multiplied by 12 gives you 84. So raised to the power of 84. Then we have plus, and we have the 2x. And this again in the bracket, notice, is the exact same thing, 1 plus this. And so that just becomes the 1.01, like here, raised to the power of 4 times 12, that is 48. Okay, so now that everything looks much neater, we can now focus on solving for X. In order to solve for X, look at the right-hand side of this equation. Notice how many terms there are here. So terms are always separated by plus and minus signs. Since we have a plus sign, it would mean that this is one term on its own, and that is one term on its own. Now, in the first term and the second term, we're going to take X out as a common factor. I know that it's not the only thing that is common. We still have this also being common, but we just want to separate the X. So we can take X out as a common factor over here. And this is what's going to happen. We open up a bracket and we're looking at the first term and saying, what must we multiply to X in order to get back to this? Or you can even just say this first term divided by X. So X and X would cancel and you would just be left with this bracket 1,01 raised to the power of 84. And then we'll do that to the second term as well. It's like seeing it as this divided by the X. And so you see the X there, and that X would cancel, and you just be left with the plus 2 and then bracket 1,01 raised to the power of 48. And then of course on the left hand side we still have this number. And now if you look at this equation, you will notice that now that we've removed the X, all of this inside the bracket, they're all numbers, and we need to just solve for X. So in order to solve for X, we can divide both sides of the equation by all of this. But looking at this looks quite messy. So something you can do is, because you know you're dividing both sides of the equation by this, it just means that this will cancel and this will cancel, and you'll be left with the X. So I'm just instead going to write it as X is equal to, and you can just say this divided by that. That's what you can write instead of putting all of this, just to avoid the chance of making mistakes. Okay, so that looks better. So if we put this all onto the calculator, and just be careful as you're putting everything in. That's why it's always important to make sure that you wrote it properly. So put it all onto the calculator and let's see what it gives us. And now we finally see that X is just equal to, so as you can see, those zeros, it's 009, so you don't have to round off to 2 decimals. It's just 50,000 Rand. So X is equal to 50,000 Rand. And that's our final answer. On question 7, and question 7 says, okay, so 7.1 says, at what annual percentage interest rate, compounded quarterly, should a lump sum be invested in order for it to double in 6 years? Okay, so be able to differentiate between when they're asking you for compound growth, future value, present value. So in this question, notice that they're just asking at what annual percentage interest rate, compounded quarterly. So this interest is compounded quarterly. Should a lump sum be invested in order to double in 6 years? So there's an amount that you're going to invest and they want it to double in 6 years' time. And they want to know at what interest rate per annum compounded quarterly should this be. So these are the things that we know. First of all, this is neither present value nor future value, because this is not speaking about payments being constantly made, the same payments being constantly made. It's one amount being invested and we want it to double after 6 years. So this is compound growth. And you know the formula for compound growth is just A is equal to P bracket 1 plus I to the power of N. Okay, so let's find out the things that we know here. First of all, they're asking at what annual percentage. So we definitely do not know the value of I. That's what we have to find out. And then secondly, they told us that something has to be invested and then it needs to double after 6 years. So in this case, this is where you're allowed to put your P value as anything, but the A value needs to be double of what the P value was. So you can use any number, it would still work out. So in this case, I'm just going to use, like, let's say we were investing in 10 Rand. And so we know that it needs to double after 6 years. So our A value, the amount we get after, would be 20. So you can also use that. And then the N, we have to find out what is N. So remember that they said they want it to double after 6 years. So we know that N is equal to 6, but it's also compounded quarterly. So we're going to say 6 multiplied by 4 to make it in quarters. And so N is going to be 24 quarters that we have. So we can go ahead and do this and we'll be able to find I. Also just remember your interest rate, whatever your interest rate is, it needs to be put over 4 because we're taking that interest and we're dividing it into 4 quarters. So we still also have to do that there. So we're saying A, which is the 20, is equal to your principal amount, which is 10, bracket 1 plus our interest is I over 4, and then this is raised to the power of 24 as N. Okay, so in order to solve for this, to find the value of I, because that's what we're just trying to do, to find the value of I, let's just get rid of 10 first. So we can divide both sides of this equation by 10. And so here, 20 divided by 10 is just going to be 2, is equal to, that would cancel, and we're left with just the 1 plus I over 4 raised to the power of 24. Then, again, in order to get to the I, what is stopping us from getting to the I? So the first problem, the biggest problem would be the 24. So we need to get rid of the 24 by rooting both sides, the 24th root of both sides. So we're going to say 24th root over here and the 24th root. Okay, now to avoid writing long numbers, I'm going to just keep leaving this like that. So over here, this cancels. And then we're going to have still here the 24th root. I'm just going to keep calling it that. The 24th root of 2. And since that cancel, we just have 1 plus the I over 4. So we need to just take the 1 over. And so we have the 24th root of 2. And then we're just taking the 1 over. So it becomes a negative 1 is equal to I over 4. And then, of course, to get rid of the 4 so that we can solve for I, we're going to just multiply both sides of the equation by 4. So times 4 and times 4 over here. But I'm just going to put this like brackets and 4. So we put in the 4 over here so that it can multiply. Okay, so what will happen here is your 4's will cancel. And now you have that your interest is equal to, if you put that whole thing on the calculator, you'll find out what your interest is as a decimal. Okay, so we just get a 0.1172, and I just stick to 4 decimals. You can write the 5th decimal just in case it was going to round up. And in percentage form, you just have to multiply that by 100. So if we say take that and multiply it by 100, we just get an 11.72% as our interest. Okay, so that is the first question, 7.1. And now we're on question 7.2. So the information reads, Simon buys furniture to the value of 10,000 Rand. He borrows the money on the 1st of February 2020 from a financial institution that charges an interest rate of 9.5% per annum compounded monthly. He agrees to pay monthly installments of 450 Rand. The agreement of the loan allows him to pay equal monthly installments from the 1st of August 2020. Then 7.2.1 says, calculate the total amount owing to the financial institution on the 1st of July 2020. Okay, so let us just create a map of what's going on here. First of all, Simon borrows 10,000 Rand and he borrows this money on the 1st of February. So on the 1st of February 2020, notice that everything is in 2020, so I'm not really going to write the dates. So on the 1st of February 2020, he borrows 10,000 Rand. Then in the information, they say that the agreement of the loan allows him to pay equal monthly installments from the 1st of August. Okay, so let's see how far it is from 1st of February to the 1st of August. So we're just saying February, March, April, May, June, July, and August. So this is when he's going to start paying. But the question is asking you to just calculate the total amount owing to the financial institution on the 1st of July. So that is just a month before August. So on the 1st of July, that's when the present value is going to be determined. So I actually find this very helpful. The fact that they're already telling you how much is he going to owe on here. So you just have to really see, how does the money grow? Because he already borrowed the money and you see that he's not paying for any of these months and he's only going to pay on the 1st of August. Now really how present value works is that when you borrow the money, you have to pay 1 month after. That's of course if your interest is being compounded monthly, then you have to pay 1 month after. So you see here, they're already telling you that you have to calculate how much he's now going to owe on the 1st of July. And that's why I say they're actually making it easier for you because you didn't have to think that through. So let's just see how the money is going to grow. Because this is a loan, it's going to keep gaining interest as long as it has not been paid for. So with loans, the interest is gained on what you owe. Okay, so how many months was this? From February. So February till May. So if we count it, that's just 1, 2, 3, 4, 5. On the 1st of July, you can see that the money is going to grow for 5 months. So we're just going to take this money and let it grow using compound interest growth formula. So that formula is A is equal to P bracket 1 plus I raised to the power of N. And so we have A is equal to the principal amount, the money that we want to grow is the 10,000 Rand. And we have 1 plus the interest being 9.5%. So we're saying 0.095 compounded monthly. So over 12, all raised to the power of. So remember, it is growing for 5 months. From here to here, it's growing for 5 months. So we're going to raise it all to 5 months. So all raised to the power of 5. Now you see, I'm not going to say 5 times 12. You only say times 12 when you're trying to convert the years into months. This is already in months. So let's go ahead and see what we get when we put this onto the calculator. And you see now that the money that he's going to owe on the 1st of July is going to be 10,402 Rand and 15 cents. That's how much he's going to owe. Then question 7.2.2 says, how many months will it take Simon to repay the loan? So now that we know how much he owes, and there's also other information that we actually know. We know how much he owes now. We know he owes this. We also know that he is going to be paying monthly installments of 450 Rand every month. And we also know the interest. So here we're going to be using the present value formula because we need to calculate how many months now he's going to take to pay them back. So remember, your present value formula looks like this. And let's just look for all the things we need to have. We need to find out how many months it's going to take him to pay them back. So we're looking for N. And these are the other things that we know. We know what the present value is. The present value is that 10,402 Rand and 15 cents that we calculated. The X is the monthly payments that he's going to be making, which they said was 450 Rand that he's going to be paying every month. We also know the interest. The interest is, of course, our 0.095 over 12. And so we need to just find N. Now, here's the thing about N. With N, I'm just going to leave N as it is. I'm not going to say times 12 because when you times it by 12, you're just trying to convert that number that you have into months. But they already told us to find out how many months it will take to repay this loan. So I'm not going to change that. And whatever I find as n will just be my months. If they asked you to convert it into years, that's a different case. Then whatever you get here being your months, you'd have to convert it into years. From months to years, you'd have to divide by 12. But they didn't ask us to convert it to years. They just asked for months. So I'm going to leave this as n, and whatever I get here will be the months. Okay, so now that we know all the amounts, we can go ahead and just put it all into this formula. So the present value, that is the 10,402.15, is equal to, your x is the 450, and then we open a bracket and we have 1 minus 1 plus our interest is the 0.095 over 12 raised to the power of negative n, which we have to find, close the big bracket, over the interest again 0.095 over 12. Okay, so something that you can start off with is this part. So you can just put this part as one fraction. So if we check on the calculator, what is 1 plus 0.095 over 12? You see that it's equal to this number. So in place of that, that's what I'm going to put here. Okay, so in that place, I'm just putting 2419 over 2400. Okay, so we have that. And now we can get calculating. So when calculating this, something you can do first is get rid of this. Get rid of this denominator out of this big fraction. And to get rid of that denominator, you're just going to have to multiply both sides by this. So I'm multiplying both sides by this. I'm saying multiply by 0.095 over 12. And I'm doing the same on this side. So I'm going to put brackets here, 0.095 over 12. So that is now gone. Then the next thing that is going to be a problem to get to negative n is this 450. So 450 is being multiplied by this bracket. We have to divide to get rid of it. So I'm saying divided by 450 on both sides. So divide by 450. And now this 450 is gone. All we have to do is actually calculate the value of this. And we can do this simply by saying we're going to put, first of all, a fraction for this whole big fraction. And then on the numerator, we'll first put this one over here, the 0 point, that fraction. So 0.095. Then I put over 12. And then you just go to the side, and in that, you're going to put brackets, and you put 10,402.15. And then on the denominator, we can put our 450. So 450. Okay, so we get a big number. We can just use it as a decimal instead. So that's easier. So we have 0.1830007, and it keeps on going. So I just do that to show I didn't round off yet. Is equal to, and we have now everything there's gone. We just have the 1 minus, open bracket, 2419 over 2400 to the power of negative n. Okay, so we're still looking for negative n. And first, the only thing we have to get rid of to get to the negative n is this 1. So we can take the 1 over. So this is where that ANS button is going to be very important. You can use that. But on here, I don't have to use that. I'll just say is equal to. And since we're taking the 1 over, we're going to have to subtract 1 from this. So it's still this same number minus 1. And then, of course, we just have negative and this bracket raised to the negative n. So in this case, I'm just going to say it's equal to, and I'm saying minus a 1. So you see that answer minus 1. The number that we get here, I'll put it in decimal form instead. So we get a negative 0.81699, and it keeps on going. It's equal to this negative bracket again. Okay, and then in order to get to that negative n still, we're going to have to first get rid of this negative. So divide both sides or multiply both sides by negative 1. It will still work. So divide by negative 1. So in that case, I'm just going to say is equal to and then times negative 1. So I'll put it in decimal form. We have just a 0.81699 and keeps going. Now we have a positive of this. That negative is gone. And we have this 2419 over 2400 raised to the power of negative n. Okay, so the only way to find the value of an exponent that is your variable, so your n in this case, is to use log. So we're going to have to use log to find this. We're making negative n the subject. So negative n is equal to, and you're going to say log of your base. The base is just the number that is carrying the exponent. So in this case, it's this base. And that's why I like to turn this into a fraction, because I feel like it's just easier to use like this. And so that was the 2419 over 2400. And then over here, you're going to have that number, which you can use as ounce. It will be fine. If you just press AC and you put all of this in and you use that as ounce, it will still work out fine. So by 0.8169, keep going. And as you can see, if I put that in, so remember, don't use this log, use this log with the base of A. So I put the 2419, 2400, and then in place of that, I just put ounce because I know that the previous answer was recorded. So I put ounce, and then this is what we get. We get negative n is equal to negative 25.6315, and keeps going. But of course, to get rid of the negative, you can divide or multiply by -1. So I'll just times by -1 this time on both sides. And so now we know that if you, of course, times that by -1, you're just going to get a positive of that. So n is finally equal to 25.63. And if you round off to 2 decimals, it's just 25.63. Now, this is where you have to decide. Go back to the question and find out what was the question exactly. The question was, how many months will it take Simon to repay the loan? Okay, so you need to give the full answer in months. In this case, you're going to have to think about it like this. Will it actually take him 25 months to pay off this loan? If you thought of that, no, it will not take him exactly 25 months to pay off the loan, because in 25 months, he's still going to be owing a little bit. That's why we still have the 0.63. Only after that 0.63 months, the loan will be paid off. But remember, you need to answer them in months. So instead of saying 25 months or 25.63 months, you can say n is finally equal to 26 months, because after 26 months, the loan will be paid off in full. Okay, and that's 7.2.2. Moving on to the next question. Then the next question, last question in this question 7, is 7.2.3 says, what is the balance of the loan immediately after Simon has made the 25th payment? Okay, so immediately after he has made the 25th payment, what is the balance of the loan? So something you need to understand about present value and when you're calculating the balance or how much a person still needs to pay after a certain amount of time is this. So I'll make a small example of this. Let's say somebody borrowed money and they had to pay it after, let's just use months to make this much more simple. So let's say they had to pay it after 10 months. So they owe money, they have to pay it within 10 months. If I want to calculate how much the person owes after 7 months, okay, I'm not going to use that negative n that I'm going to put, that value of n. It's not going to be 7. I cannot put 7. It's not future value. It's present value. When you want to find out how much a person needs to pay after a certain amount of time, you need to give them the amount of years they still have or the amount of months they still have left to pay. That's what is going to be your n. So in this case, we're not going to put 7 months, because after 7 months he has been paying, and now how much does he owe after 7 months? We're not going to use 7, we're going to use 3, because he has 3 months to go. That's how you use this. So that's how you put n when we're trying to find out how much a person's balance is or how much they still have to pay. You put the amount of months or years that they still have left to pay off the loan. So in this case that we're looking at, it took him, okay, so when we look at how long it actually took him, the exact amount of months it took him to pay off this loan was not 26. At 26 months, he's paying off even more than the loan already. It took him 25.63 months, exactly there. So we're looking at it like this. If it took him 25, let's say this is the 25.63, and it kept on going 1, 5, 1, and all of that. right? It took him that amount. We want to find out how much does he owe at the 25th month. So it's just like in the previous example where you had the 10 months and wanted to find out how much he owes after 7 months. You're going to have to say this 10 minus the 7, and that is 3 months. We're going to put n as 3 months. The same way here you would do the same thing because we need to put how many months you still have left to go. Here we're also going to say this 25.6315 minus the 25. And of course, you're taking 25.63 that minus the 25. It's just going to remove that whole number of 25 and you're going to be left with 0.6315, and that keeps going. That's what is going to be our n value. So something I like to do, I like to use the exact amount. So over here, I will take ounce and minus that by 25 because I want to find out what that 0.6315, I just want to use only that number. So I'm saying it's equal to, then I'm saying minus 25. So there's the 0.63. Okay, so we're going to use the present value formula. We're going to put everything in except for the present value because that's what we want. We want to find out what is his present balance after 25 months. Okay, so remember the present value formula looks like this. And so this is what we're going to put. Present value, we're finding out what that is. He is paying monthly installments of 450 Rand. And we have 1 minus 1 plus at an interest rate of 0.095 over 12 raised to the power of negative, and we are putting that amount in. So that ounce button is going to help you a lot there. So 0.6315, and it keeps on going. Or you could use that ounce for it. Okay, so then we're going to have over 0.095 over 12. And let's go ahead and see what the present value is. So on my calculator, it's a bit different. On yours, you could have just pressed the AC, put everything in, and in place of that, you could have put the word, that ounce over there, because it has recorded this number. So there is, it will probably also look something like this for you. So there's the negative ounce. Please don't forget to put it as negative because n is always negative in present value. And so the present value that we get is this amount. So it is 282.3, and I'm just going to round off the 2 decimals, 36. Okay, so that is the exact amount that he is going to owe immediately after the 25 months. So question 6.1 says 12,000 Rand is invested in a fund that paid interest of M% per annum compounded quarterly. After 24 months, the value of the investment was 13,459 Rand. And we have to determine the value of M. Okay, so money was invested. It grew at a specific interest, compounded quarterly. And then after this amount of months, the value of the investment is this. This is a simple case of compound interest growth. So we're going to use the compound growth formula. Okay, so something that I like to do is I write down the variables that I'm going to have in that compound interest formula. So that is the P value, the A value, I, and N. So you can just remember that acronym PAIN. So I'm going to find the P value. What is P? P stands for your investment. So P, in this case, 12,000 Rand was invested. So we know what P is, 12,000 Rand. And then A, what is A? The A value is the accumulated amount. So the amount that you have at the end of that period. They told us after 24 months, the value of the investment was this. The value is now this amount. So that's our A value. So A is 13,459. Then the interest. The interest, they told us that the interest is M% per annum. Compounded quarterly though. So whatever M is, for example, let's say it was like 14% per annum, right? You would naturally say, oh, okay, that's 0.14 as a decimal. Then because it's compounded quarterly, you would remember to divide by 4 so that it's going to be in quarters. So I'll say over 4. So so that it's shared into 4 parts and it ends up gaining interest every quarter. So I'm going to do the same thing for M. So treating M, because they said percent, I'll treat it like it is a decimal. Okay, you can say 0.m if you want, but it's not really necessary. We can just say M and then divide it by 4. And then we'll sort that out at the end and just make sure that we tell them the answer as a percentage. Okay, because they do say M%. Now we have to figure out N. So N is the time period. Okay, they tell us that it is after 24 months. But we also have to remember that this is compounded quarterly. So how many quarters is 24 months? One way we can convert this is, normally, they usually give you this information as years, right? They would tell you, let's say this thing has been invested for 7 years. So if you knew that was 7, you would have just said, oh, N is equal to 7 times 4 to put it in quarters, right? Instead, they didn't give you this number in years. They gave it to you in months. So how about you just convert 24 months into years, then convert it into quarters. 24 months into years, because 12 months is equal to 1 year, right? To convert 24 months into years, you would just divide that by 12. So this is going to be equal to 2. 24 months make up 2 years. So I'm going to say 2, and then I need to turn these years into quarters. So to turn into quarters, I'll just multiply by 4, because quarters is in 4s. And there we go. So this is going to be 8. And now everything is set. We can just use the formula. It is the compound growth formula. So that is A is equal to P multiplied by 1 plus I raised to the power of N. And so A is 13,459, which is equal to 12,000. And then 1 plus the interest is M over 4 raised to the power of 8. And we just have to try and solve for M. Okay, so to get to M, what do we do? Okay, so first of all, the first problem I see here is there's 12,000. We have to get rid of it. If we divide both hand sides by 12,000, we will get rid of that 12,000 over there. So that's now gone. And then let's see what this is going to give us. Okay, so what I noticed is that it gives me a fraction. It does not simplify. And the decimal is quite long. I would rather not use decimals, because when you use decimals, if you round off, it's going to change your answer. So I'm going to leave it like this. I'm not going to change that. I'll leave that as a fraction. And so what I just have here is I have the 13,459 over 12,000. And then this is equal to, we have now 1 plus M over 4 to the power of 8. Now, we're still trying to get to M. The next problem that we have here is this 8. It's blocking us from getting into the M. So we can go ahead and root both sides, but find the 8th root of both sides. So the 8th root and the 8th root. And from the way this looks, I'm not even going to find the answer of this. I'm just going to keep leaving it like this. Now the 8th root is going to cancel and it's gone. And we have now, again, I'm just going to rewrite the 8th root of this number, not changing it because I don't want decimals. And then this is equal to 1 plus M over 4. Now to get to the M, what's stopping you from getting to the M? It is now the 1. So just take the 1 over. So that's this same thing again. And when 1 comes over, it becomes negative because it becomes the inverse. So I'm just taking 1 over, say minus 1 is equal to M over 4. Okay, now at this point, still trying to solve for M. What is stopping us from solving for M? It's the 4. Now you have to ask yourself, what is the 4 doing to the M? Well, it's dividing by the M. So to get rid of it, you have to do the opposite, which is to multiply by it. Okay, so multiply both sides by 4 to get rid of that divided by 4. Okay, so this is how I'm going to rewrite this so that it can get me the answer. I'm trying to multiply this entire thing by 4. So I will use brackets. Okay, so it's like 4 multiplied by the 8th root of 13,459 over 12,000 minus 1, is equal to M. So now we can find out what M is equal to. So I'm going to put this onto the calculator as 4 bracket, then I'm finding the 8th root. So I'll press shift and this. Okay, so just check on top. You should have one with an open number for root. So I'm putting 8, and then inside we're going to have a fraction. So I'm putting 13,459 over 12,000. Then we're going to come out of that radical, use your buttons on the side. Then we're going to say minus 1 and then close that bracket. Okay, so weird number, but I'm just going to press SD so that it can be as a decimal. Okay, so it is 0.05778. I usually leave 5 decimals and then show that I didn't round off yet. But now remember that M must be a percentage, because they said at M% per annum, just like they would say at 12% per annum or 14% per annum. You're going to have to leave that as a percentage. So to get this decimal to be a percentage, you need to multiply it by 100. So I'm going to take all of that answer and I'm going to say multiplied by 100, and let's see what we get. So we get this. So M is equal to, as a percentage, M is 5.78, because it rounds up, 78%. There we go. And that's our answer. Okay, moving on to the next question. Then we move on to 6.2, and 6.2 says, on the 31st January 2022, Tino deposits 1,000 Rand into an account that paid interest of 7.5% per annum compounded monthly. He continued depositing 1,000 Rand, so continued depositing, meaning money keeps going in and is constant, the same amount, meaning this is future value. Okay. So he continued depositing 1,000 Rand on the last day of every month. Last day of every month. This is he's being consistent in his deposits. Okay. Then he will make the last deposit on the 31st of December 2022. So from 31st January to 31st December. That's just 1 year. Okay. Will Tino have sufficient funds in the account on the 1st of January 2023? So he stops here. That's the last deposit. Then the 1st of January. If you look at those two dates, you see that that is just 1 day away. So it's not going to earn extra interest. Okay, so on the 1st of January, to buy a computer that costs 13,000 Rand, justify your answer by means of an appropriate calculation. Okay. So as we can see, this is a future value question, first of all, and he's just depositing for a specific amount of time. All the information is given here, and we just want to find out, will he have enough money, okay, to buy a computer that costs this? So we're not really taking this as the future value, because we don't know what his future value is yet. We have to use the information that we have about him, meaning when he starts depositing, when he ends depositing, the amount he keeps depositing, and the interest at which his money is gaining interest. And we're going to use that to find out how much he will have. Then we will compare it with the 13,000 to see if he actually has enough money for that new computer. So first of all, let's focus on the deposits. They told us that on the 31st of January, right, that was 2022, that he deposited 1,000. Then he continues, okay, that paid this. Then he continued depositing 1,000 on the last day of every month. He deposits first on the last day of January and then every other month all the way till the 31st of December, which is also the last day of December. So from the 31st of January all the way to the 31st of December, also 2022, these are all the deposits that he's making. He's making deposits of 1,000 Rand. Okay, so let's count how much deposits this is going to be. And remember, the amount of deposit in your future value formula, that is your end value. So the amount of deposits from the 31st of January to the 31st of December will be a total of 12 deposits, because it's deposited every month. Okay, from January to December, there are 12 months. So N is equal to 12. We know that. So if we write down our future value formula, just so that we know what to look for, our future value formula is this. We have x, open bracket, open a small bracket, 1 plus I, raised to the power of n minus 1 over I. Okay, so let's look at what they asked us to find. We just have to find out, will he have this amount? So let's find out how much his future value is going to be. We're trying to look for the future value, first of all. What is the X amount? Okay, the X is basically how much he keeps depositing consistently. That is the 1,000 Rand. He keeps on depositing 1,000. So we know that. And then the interest is 7.5%, but we need to put that as a decimal. So 0.075. And did they tell us the compounding? They said compounded monthly. Okay, so 0.05 divided by 12. It needs to be shared into 12 months. Then we have N. Now N tells you the amount of deposits. Okay, and we know how many deposits that is. That is 12 deposits. Okay, so other than this, there's nothing else. There's no other special thing happening, because we just have to find out how much it's going to have on the 1st of January, which is just a day away from that last deposit. So no interest will be earned, because interest will only be earned every month, compounded monthly. Okay, so we're just going to put this into the formula. This one is quite simple. So this is equal to future value will be equal to 1,000. So using that, open bracket 1 plus 0.075 over 12 raised to the power of 12 minus 1, and then over 0.075 over 12. And you could just put this onto the calculator and let's see what we get. And this is how much we have. So we're going to round off to 2 decimal places. He ends up with 12,421 Rand, and round off to 2 decimal places, 22 cents. So all we have to do here is, this is how much Tino saved up, right? The question is, will he have sufficient funds in the account on the 1st of January? Remember, the 1st of January of 2023 is just 1 day away. He doesn't earn any interest. So we already found that. We just have to find out, will he have enough money? This is how much he has in his account. So will he have enough money? He was supposed to save up 13,000, but he only saved up 12,421. Okay, so no, he will not have enough money. So I'm just concluding, he will not be able to buy the computer because he will be a specific amount short, and we can just find out how much short he is. Okay, so he will not have sufficient funds to buy the computer because he will be, now I'm just calculating how much he needs extra. So he needed 13,000, but he only has this. So if we say 13,000 minus the 12,000, we will find out how much short he is. So just go ahead and say 13,000 minus the 12,421.22 cents. Okay, so because he will be, and as we can see, 578.78 cents short. So he will not have that amount. Okay, so that is all for this question. Okay, so we are on question 6.3, and 6.3 says, Thabo plans to buy a car that costs 250,000 Rand. He will pay a deposit of 15% and take out a loan for the balance. So he's paying a deposit of 15%. The remaining is going to be the loan. Okay, the interest on the loan is 13% per annum, compounded monthly. 6.3.1, we have to calculate the value of the loan. Okay, remember, he is buying this car. It costs this amount. He's going to pay 15%, and then the remaining is going to be the loan. So if you can find out how much he's going to pay off and remove that from the loan, you'll find out how much he's going to take out on a loan. So the car costs 250,000 Rand. He is only going to pay a deposit of 15%. This is the deposit. Okay, so 15% is the deposit. The remaining is going to be the loan. So think about it. If 15% was your deposit, how much is going to be the loan? The loan is going to be whatever 100% minus the 15% is. That would be the remaining part. That's the loan. And that's going to be 85%. So we just have to find that. So we have to just find out what 85% of this money is going to be, and that will be our loan. So you could just say the loan is going to be equal to 250,000 rand multiplied by 85%, which is 85 over 100. And so this is going to be equal to, let's just see what we get. And that is 212,500 rand. So that is how much the loan is worth. Okay, that was for 1 mark. Yeah. So moving on to the next question, 6.3.2. So the next question says, the first repayment will be made 6 months after. Okay, let's take note here. First repayment is going to be made 6 months after the loan has been granted. The loan will be repaid over 6 years, okay, after it has been granted. So full period of 6 years. We have to calculate the monthly installment. Okay, now this is present value because now we are trying to find out the repayment on a loan. When you speak about loans or anything that was borrowed and you have to pay it back, that is going to be present value. Future value would be for anything that is being saved up. You see, money is being saved up or anything's being saved up and it is consistent. It's a consistent amount that you keep saving for a consistent time period, like every end of the month or the beginning of the month, then that will be future value. Okay, so in this case, this is present value. So I'm going to actually write down the present value formula so that we can just focus on the things we are specifically looking for. So the present value formula is x, open bracket 1 minus 1 plus I raised to the power of negative n. Don't forget that n must be negative over I. Okay, so this is our present value formula, and let's focus on everything that they're asking for. First of all, they told us to calculate the monthly installments. So the installments that you're going to pay, that is x. So we're looking for x. That means we have the present value. So we have to see what the present value is going to be. Now, the loan amount is this. But now the reason I can't jump to the conclusion that, oh, okay, this is the present value is because they said something. They said the first repayment will be made 6 months after the loan has been granted. See, this is what this is going to do to this account. He's making this payment, the first payment, 6 months after. On a timeline, this is going to look like this. So we're going to have T0, where the loan is granted. So granted. And then he starts making his payment only 6 months after. So I'm treating these as their months. At T6, he starts making his payments. This is how you have to think about this. The loan was granted. The loan of how much? This amount. This 212,500. That was the amount granted. But he only starts paying here. Okay, you have to remember this rule about future value and present value. In present value, you always start paying back your installments 1 month after. This is, of course, if you have been given an interest that has been compounded monthly, then you're going to have to start 1 month after. If it was compounded yearly, you're going to start 1 year after. If it was compounded quarterly, you will start 1 quarter after. So you always start 1 period after. So this is what I'm saying here. Here, his loan is granted at T0. He was supposed to start paying 1 month after, which would be at T1. The problem is he didn't start paying at T1. He started paying 6 months after the loan was granted at T6. So he has missed some payments, but you're going to have to count how many payments was missed. So to calculate the amount of payments that he missed the first payment, the second, the fourth, the fifth, and then he made a payment here. See, because he starts paying at the 6 months. So first payment was made 6 months after. He starts paying here. Of course, that is 6 months after that loan was granted. Okay, so he was supposed to pay here. That means that he missed 5 months. Okay, 5 months of worth of payments was not paid. So we have to remember that the missed payments was 5 months. So because he missed 5 months, he's not going to owe this anymore. He missed 5 whole months. This money is going to grow for 5 months, and that's what he's going to owe. So we need to take this money and at the interest rate that this account is being charged for, which is the interest rate they already mentioned here, 15%, right? And of course it is per annum compounded monthly. So we're going to have to grow this money for 5 months using the compound growth formula. So that would be A is equal to P bracket 1 plus I raised to the power of n. Okay, so A is equal to, and we're going to take this amount and grow it, okay, for 5 months. So 1 plus, what was the interest? Okay, so 15% is not the interest. That is just the amount that he's paying from the deposit, basically. Okay, so how much he was depositing. So 13%, that is the interest on the loan. Okay, so let's just keep that in mind. 13% is the interest on the loan. So I'm saying 0.13 over 12, because it's compounded monthly, raised to the power of 5. I don't have to times this by 12 because this is already in months. I'm growing it for 5 months. Okay, so you can put this onto the calculator and see what you get. And we get 224,262.53 cents. That's how much he ends up owing. Okay. Now, to be safe, I actually wouldn't round off. The reason why is because this is not the final answer. The final answer is to find X. Okay, to find the monthly installment. So I would actually just leave this to be safe to 2 decimal, to at least 4 decimals. That should be good enough. So I'll say 544, and I'll just leave it like that. So 54. Let's just stop there, just to be safe. Okay, so now we know how much he owes. That's the present value. That's your loan amount. Present value will always stand for the amount the person owes. This is how much he owes. So that is that amount, 224,262.5254. I'm just leaving it at that. So we have X, we have P. What is the interest? We already know that the interest is 0.13 over 12. The interest for that whole loan account is that. And then N. Now we have to figure out what N is. Now remember, in your present value formula, they already tell you N is always going to be the number of payments you must still make. Okay. Number of outstanding payments. Okay. So let's think this carefully. This loan is going to be for 6 years. They said 6 years already, okay? They did tell us that it has to be paid within over 6 years. So how many months is 6 years? Because these are already in months. See, 5 months was missed. This is the 6th month and so on. So to find out how many months 6 years is, we just say 6 times 12. And 6 times 12 is equal to 72. So 72 months. That's what we have. So we ending at T72. Okay. We are counting how many payments he must still make. He starts paying on the 6th month. So this is one payment over here. Then the next payment happens on the 7th month and the 8th month and so on. So how many payments is going to be made? Well, you're going to have to think about this carefully. Let me give you a small scenario. Let's say we started paying at T3 and we ended our payments at, let's just say, T7. If you said, oh, okay, to find out the amount of payments I must make, I must just say 7 minus 3 and that's my answer. That would be wrong because T3 is a payment itself. This is a payment. T4 is a payment. T5 is a payment. T6 and T7, they're both payments. Now, if you look at that carefully, you see you have 1, 2, 3, 4, 5 payments. It's one more than the amount here because you have to include T3 itself. So just be careful with that. So in order to find the amount of payments, I'm just going to say 72 minus 6, right? Because that's where he starts paying. And 72 minus 6 is, so 72 minus 6 is equal to 66, right? But now I have to remember that I also have to include that 6th payment itself. So plus 1, just like I just showed now with the T3 to T7. So that is going to be 67 payments. Okay, that is the value of N. N is actually equal to 67. So now that we have everything, we can use the present value formula and solve for X. Okay, so putting everything down. Present value is equal to, and then I'm just going to put the formula down again. So the present value, we know what that is. That is this amount, 224,262.5254 is equal to, and then x, we don't know what that is. We're looking for the value of x. And then we open a bracket, 1 minus 1 plus the interest, 0.13 over 12, raised to the power of negative 67, and then over that interest. Okay, so we're just trying to solve for x. Okay, so to solve for x, you would notice that you see all of these, they're all numbers and they're being multiplied to x. So in order to get rid of them, you could just divide by everything that is here. So if I divide by everything that is here, what you do on this side, you have to do on the other side because this is an equation. So really, to solve for x, we can just say this number on top divided by this whole thing here, okay, because that is that. So there. Now, to be safe, what you can do is you can change the way this was written. You don't have to write it like this. It's not necessary. You can do this if you are sure that you can put it on the calculator safely, but you could have also done this. Take this number on top and then just say divided by all of this. So like this, okay? You could have also done that. I'm just going to do this method though. So I'm going to put this onto the calculator and then let's see what we get. Okay, so this is what we get. We get x is equal to 4,724 Rand and 96 cents. And that is the value of x. Okay, so that's how we actually find this. So just be careful to read the question carefully and just take note of everything that they do speak about. Okay, so now we're on question 6, and question 6.1 says, a company bought a photocopier for 150,000 Rand on the 1st of July 2020. They will use the old photocopier as a trade-in when they replace it with a similar new photocopier in 5 years' time on the 30th of June 2027. So 6.1.1 says, the average rate of inflation over the next 5 years will be 6.5% per annum. Determine the price of a similar new photocopier in 5 years' time. Okay, so this company, they bought a photocopier machine for this price. So it means that in the present, like right now, they have this photocopier machine and this is how much it costs. They want to find out, since the rate of inflation is this, they want to buy a new photocopier machine, but this one is going to be in 5 years' time. So this is the one that is in the future. Okay, so it's going to grow. Okay, so because of the rate of inflation, the price of this will not be 150,000 Rand anymore. It will increase in value. And so something you need to remember is when we're speaking about inflation, then we're going to use compound growth formula. And that formula is A is equal to P bracket 1 plus I raised to the power of n. Okay, so in this case, the A value is going to be that final amount because this money needs to grow. So we're taking this is your P value because we invest in this and we need to grow it over 5 years. So that is the 150,000 Rand and then 1 plus, and the rate of inflation is 6.5% per annum. Okay, it's not compounded monthly or anything. So the interest in decimals is going to be 0.065 as a decimal. So plus 0.065 raised to the power of 5. Okay, so let's go ahead and see what this gives us. And on the calculator, this is what we get. We get 205 and then 5, 1, 12, but then you see 0.999. So it's money, it usually has to be rounded off to 2 decimals. So if you rounded off that 9, it will round up and then cause that 9 to become a 1. And so it will just round up until this 2 becomes a 3. So the money that we'll have here, the price of that machine is going to be 205,513 Rand. Okay, so that is the amount there. Then the next question. Then 6.1.2 says, calculate the trade-in value of the old photocopier after 5 years if it depreciates at 9%, a rate of 9% on straight line method. So it is depreciating first of all, and it is on straight line method. So this is simple decay, and the simple decay formula looks like this. A is equal to P bracket 1 minus I multiplied by N. Okay, so then another thing we need to look at is the fact that they said they need to calculate the trade-in value. So we have to find what is the trade-in value. Trade-in value would refer to your final amount, because this is the money that machine can be traded in for. So it just means it cost a certain thing before, then over time it depreciated, then you can only trade it in for that amount. So that is your final amount. As you can see, the money here is going to decrease. Other words for trading value is things like this scrap value as well. Okay, so when you see those, that's what it refers to, that final amount. Okay, so we're going to have the amount that we're putting for P is going to be this present machine that they have. We want to know what is going to be the value of it when it depreciates. So it's our starting amount. So we have 150,000 and then bracket 1 minus the interest. Then the interest is 9%. As a decimal, that is 0.09. And then multiply by n. So not to the power of n. Multiply by 5. Okay, so let's go ahead and see what this gives us. And the final amount we get for A is 82,500 Rand. So that's how much that machine is going to depreciate to over 5 years. And that's how much they're going to be able to sell it for. Okay, moving on to the next question. So 6.1.3 says, the company set up a sinking fund to cover the replacement cost of the new photocopier machine. Okay, the minute you hear sinking fund, this has to do with future value. And anytime they speak about anything related to a savings plan where you're constantly putting the same amount of money every month or every quarter or every year, then that is where you're going to need future value. That's where you're going to use the future value formula. Okay, so they say the fund earns interest at 7.85%. Okay, so that is the interest per annum compounded monthly. Then they say the company made its first monthly deposit on the 31st of July 2022 and will continue to do so until the 31st of May 2027. And they're specifying that this is 1 month prior to the new photocopier being bought. Okay, when they're saying 1 month prior, so prior is just before. So 1 month before the new photocopier was bought. So that's going to be an important factor that we're going to look into. And the reason why is it's not like the normal ones they speak about where they tell us the payment started 1 month after. That's normal. In every future value or present value calculations, payments usually start 1 month after. But this is not the case. They are saying that they started the payment on this day and they will end on this day. But this is 1 month before the new photocopier is bought. So if they started on that 31st of July 2022, let me just call it June 2022, all the way to the 31st of May 2027, right? But this happens to be 1 month before they purchased the new photocopy machine. So this is the new machine that is being purchased. Then it means that the money, this is future value, meaning they're saving money. The money they've been saving at some point sat in the account for an extra month. So that's what that part means. It's not really like the usual 1 month after that they speak about. This is different. Okay, and then they say how much should be deposited at the end of each month so that the company will be able to buy the new photocopier. Okay, so how much must they deposit at each month? So that is basically the value of X. We need to find the value of X. So we're using future value. The future value formula looks like this. X open bracket, then 1 plus I raised to the power of n minus 1 all over I. And just remember, you also have a formula sheet, so you can always go back and check. Okay, so since this is our formula and we just need to find X, then it means let's just go ahead and fill in every other thing that we have. It means we should be able to find the future value. we should also be able to find the interest, which they actually told us the interest. That is this 7.85. In decimal form, you can put it as 7.85 over 100, and it's going to simplify it for you. So you can take it as 0.0785. And then another thing we would have to find is the value of n as well. Okay, so how many months is that going to be? Okay, so these are the things we can find, but when we do find them, we need to actually calculate the value of x. Okay, so we can start with the future value. The future value will be calculated like this. In sinking funds, when you want to calculate the future value or the amount that they're going to need to save, you calculate it like this. So remember, they had this machine. They bought it for 150,000 Rand. Then in 5 years' time, this current machine they have is going to depreciate, and it depreciates to become this amount. Then they know that in 5 years' time as well, they're going to need a new machine, and that new machine is going to cost this amount. So they're not just going to throw this machine away, they're going to sell it. So if this was the amount that they actually needed for a new machine, but they're going to sell this amount, then you can calculate how much they actually need by saying this amount minus that. Since they're not throwing this away, they're going to sell it. So they're going to have that money as well to contribute towards getting this amount. So that's how we find the sinking fund amount. That's how much will be in the sinking fund. Or rather, that's the amount that they will need in the sinking fund. So that would be the sinking fund amount will be equal to that 205 and that minus this. Okay, and we're going to put this on the calculator and see what we get. And we get 123,013 Rand. Okay, so that's how much they need in the sinking fund. And that's really going to be our future value. Okay, so that is the future value that we're going to be using. Now, with this as well, this is compounded monthly, so this should be over 12. And then now to calculate N. So let's see what they said. They said that the company made its first monthly deposit on the 31st of July. Okay, so the first one was made on the 31st of July. And then they said, and will continue to do so until the 31st of May 2027. Okay, so this was in 2022. So we can go ahead and put that there. So this was in 2022, but they will continue to do this until the 31st of May 2027. So let's see how much months this is going to be, since it is compounded monthly. Okay, so a way that you can calculate this is, let's actually calculate it in terms of its years. So in 2022, how much months did they start depositing for? So they first started on the 31st of July. Okay, so July. And then we're going to have August, September, October, November, and December. Okay, so that is the 31st of December. So this is just the year 2022. This will be the amount of deposits they're going to make. So that is 1, 2, 3, 4, 5, 6. Okay, so here that is 6 months that they're going to be depositing for, seeing that they started here. Okay, so that's 2022. Then we can calculate their deposits for 2023. So in 2023, they're going to deposit from January the 31st, so Jan, all the way to December the 31st. So 31st December as well. And that from January to December of 2023, that would be 12 months. Okay. Then we can look at 2024. So in 2024, what's going to happen is, again, they will start depositing on the 31st of January and stop at the 31st of December. And again, that would be 12 months. Then in 2025, they're going to start depositing on the 31st of January again, all the way to December, 31st of December, and that would be 12 months as well. Okay, and then lastly, we're looking at 2026. So in 2026, they're going to deposit on the 31st of January and end on the 31st of December, which would also be 12 months. Now in 2027, they don't deposit all the way to December. They deposit from the 31st of January, and then they said that they're going to end here on the 31st of May. So let's calculate how much months that would be. So January, February, March, April, May. So till the 31st of May. And so that is 1, 2, 3, 4, 5. This is 5 months. So we counted it as if this is the money that they are putting in. Okay. So the amount of installments that we have. So if we calculate all the way from the 31st of July here, all the way to the 31st of May in this year, this is the amount of months. So it's the 6 months. So N will be equal to the 6 months first, plus the 12 months, plus the other 12 months, plus this 12 months. And we keep going, plus this 12 months, plus that 5 months. So plus 12 plus 5. Okay, so you could just calculate it like that. And we already have how many sets of 12 here? This is 1, 2, 3, 4 sets of 12. So it's really just 6 plus 4 times 12 plus 5. And in total, that is 59 months. Okay, so N is equal to 59 months. Okay, so now we know what N is. That is 59. So 59 months. So everything is now ready to find X. So now we have to calculate the value of X. Remember, it's using the future value formula. I'm just going to copy this and put it down there. Okay, but there was also something that we really need to look at. So they said that they started depositing here on the 31st of July 2022. And then they will continue to do so until the 31st of May 2027. But then they said that this is 1 month prior to the new photocopier being bought. Meaning, like I said here, they started here, they ended here, but they're only going to buy the new machine a month after. Meaning the money, okay, that they keep depositing into this account is going to sit for an extra month. So this needs to grow by an extra month. And we need to apply this into our formula. So we'll apply it by doing this. All of this amount is going to give you your future value, okay? That's what this formula is for, to give you the future value. So we need to take that and now grow it for an extra month by multiplying it by 1 plus I to the power of the amount of months, and it's only growing for 1 month extra. And remember, the reason you say 1 plus I is because you want the future value itself, the money, okay, to be there, plus the interest as well, because this actually foils in like that. So that would be, when it multiplies by the 1, that will be the future value itself. And then when you multiply it by the I, it will be the interest of that future value. Okay, so when we're putting this in, we're going to have the future value, that's the amount we have, 123013 is equal to, then we have, I'm going to put this lower, it's going to look messy, and then we're going to have the X, and then open a big bracket, small bracket, 1 plus the interest 0.0785 over 12. So when you're filling these in, just be very careful. And we have to the power of 59, and then minus 1, close the big bracket, over the interest, which is 0.0785 over 12. And then, of course, this is being multiplied by this part. So multiplied by the 1 plus the interest, which is 0.0785 over 12, raised to the power of 1 month, if you want to say that. But it doesn't really matter. There's an invisible exponent of 1 here. Okay, so this is what we have now. Okay, so I'm going to try and calculate this in a way that it's going to look less intimidating, because the numbers, yeah, they look very complicated right now. So I'm going to focus on what are numbers here. Here we just have an X, and this X is being multiplied by this whole thing. But remember, this is being divided by this. So if you like, you could have said this entire thing here, all of these numbers divided by that, and it will give you a single number. And then that is being multiplied by this whole thing. So what we can do is, on the calculator, put this over that and multiply it by this. and it's going to give us a number in decimals, and we will not round off. Okay, so I'm going to put it in like this. Start with a fraction and then open bracket and then another bracket, 1 plus 0.0785, so 0.0785 over 12, and then we move out of the bracket, close that bracket, raise it to the power of 59, then come down, and then we need to say minus 1, so minus 1, we close the bracket, and then we go over 0.0785 over 12. I'm just trying to be careful here. Then, okay, so that part is done. And just check and make sure that everything's okay. Okay, and then we're going to multiply by this little part here. So multiply by 1 plus 0.0 and then 785 all over 12 raised to the power of, so come out of that, close the bracket, raise it to the power of 1. You don't have to do that actually, because there's actually an invisible exponent of 1 there. Okay, so this is the number it gives. Just make sure you check that everything is in properly. So this is really what I'm saying. Here we just have the 123,013 is equal to. Then we have the x being multiplied by everything here. So it's like x multiplied by the 72.19028,117, and you can just say dot 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 just to show you did not round off yet. Okay, and now to solve for x, to get x to be on its own, we will just have to get rid of this number. So we'll divide both sides by 72.1902 dot dot dot, divide both sides by 72.1902 dot dot dot. Okay, so I'm solving for x here. Now, there is a button on your calculator that's going to be very useful, and it's this button called ANS. So it is the answer button. Whatever amount you calculated here is recorded in this button. So if you remove everything here, if you press AC, which I'm going to do, if you press AC, it's going to show you the last answer that it recorded. So we really need to just say this 123,013 and divided by this amount. So you can divide it by that amount, or you can say 721902 to them, but then on your calculator divided by ANS, because that amount has been recorded in there. Okay, so on your calculator, mine works a little differently. You can press the AC button, then you put this amount in and say divide by ANS. So over ANS, or even if you use division, it will still work. Okay, so on my calculator, I just have to first say is equal to, and then I'm going to say that 123013, and then over ANS. Okay, so this is how much we get. So over ANS, we get 1,704 Rand and 01 cents. Okay, so that's the amount. This is how much they need to keep putting into this account for that 5 years in order to be able to buy a new machine. Okay, so that is this question 6.1.3. Okay, in financial maths, just be really careful with the numbers. You know how it is. They always put complicated numbers and try to simplify things the way you can. That answer button is very useful on the calculator. Okay, so moving on to the next question. Okay, so 6.2. Today, Andrew borrowed 200,000 Rand from a bank. The bank charges interest at 5.25% per annum, compounded quarterly. Then they say Andrew will make repayment of 6,000 Rand at the end of every 3 months. His first repayment will be made 3 months from now. Okay, that is normal. Okay, and the reason I'm saying this is normal is because when you get a loan, for example, so if you get a loan on this day, T0, you always have to start paying back the loan a period after. And when I'm saying a period after, I just mean, for example, if your interest was compounded monthly, then you need to start 1 month after. So if your interest was compounded quarterly, you have to start 1 quarter after. And a quarter, okay, 1 quarter is actually equal to 3 months. So it makes perfect sense that they're saying that his first repayment will be made 3 months from now. Okay, because that's just how loans work. Okay, so how long in years? In years will it take Andrew to settle the loan? Because they're already speaking about loan, we are going to use present value. Present value always calculates the repayment on loans. So present value formula is X, and you can always just go back to the formula sheet. X bracket, then we have instead a 1 minus bracket 1 plus I raised to the power of negative n, close bracket, over I. So that's our present value formula. Okay, so with this formula, we can find all the things they are asking for. So the first thing we're going to look for is, they said, today Andrew borrowed this amount. This is his loan amount. So the present value is this amount. You can see present value is really how much do you owe. So since Andrew went to the bank today and borrowed this amount, today he owes 200,000 Rand. So that's his present value. Okay, so he owes this amount today because no month has passed yet for there to be interest. And then we also find out that they also tell us the interest, 5.25% compounded quarterly. So our interest is in decimal, 5.25 is 0.0525, and then it's compounded quarterly, so we put it over 4. Okay, and a way of looking at that is like, this is the yearly interest. They say per annum, compounded quarterly. This is the yearly interest that they give him, but then it's going to be compounded quarterly. So he's going to be charged interest every quarter. Then they also say Andrew will make repayments of 6,000 Rand, okay, at the end of every 3 months. That is normal. At the end of every 3 months, 3 months is a quarter. So the repayment amount, that is going to be your X value. So X is the 6,000 Rand that we have. At the end of every 3 months, and they say his first repayment will be made 3 months from now. That's fine. So the question is, how long in years will it take Andrew to settle the loan? Okay, so how long in years? So this one, it doesn't really seem like they put in anything complicated. It just seems like a normal type. So we're just trying to find n. Okay, so they probably just want to test your use of log. Okay, so let's put this in. So present value 200,000 Rand is equal to, and then we have X, 6,000 Rand, and then that is 1 minus 1 plus the interest is 0.0525 over 4 raised to the power of negative n. We don't have that. Okay, there's something that I can't just leave n like this. It wouldn't make sense. So n, the value of n itself, that would tell you your years. Because you notice when they tell us, let's say the person had a loan and they had to pay it in 10 years, then you would say 10, and then if it was compounded monthly, you would say 10 times 12. So that N stands for the years. Since they said they want the answer to be in years, I'm going to actually keep this as this. I'm saying that whatever my years was is being compounded quarterly. So I'm going to multiply that by 4. And here I'm going to be using 4n. Now notice 4n is going to stand for the quarters. I'm still going to convert that into years by dividing both sides by 4. Okay, so this will be the quarters so long. So we're raising it to the power of 4n as the quarters. Okay, over the interest, which is 0.0525 over 4. Okay, so in this one, we have to make this the subject. So we have to find a way to simplify this so that we don't make mistakes and we're able to find that n. Okay, first of all, what I will do is this 6,000 is being put over this. Okay, we can actually say this divided by that, and that amount, we'll just put it in front of this big bracket. So I'm going to say the 6,000 over this. Okay, instead of over, let's use the division sign. 6,000, since we're dividing by a fraction, divided by 0.0525 over 4. Okay, so that's the amount that we get. Can it be put as a fraction? Yes. Okay, so I would rather use it as a fraction because the fraction does not round off. So it just means here on the left hand side we still have the 200,000, And then on the right hand side, we have this number. So just count the zeros and see how much this is. That's 3 zeros. Okay, so it's 3,200,000 all over 7. And this is being multiplied by everything in here. So I'm also going to try and simplify some stuff here inside this bracket here. So we have now 1 minus, this can be simplified. Okay, so I'm going to say 1 plus there's 0.0525 over 4. As a fraction, this is what that gives. So I'm going to leave that as a fraction. It's better as a fraction. It's easier to use. So it's 1621 over 1600 to the power of negative 4n, and then close that bracket. Okay, so this is what we have. We're still trying to solve for this. Okay, since we're trying to get into this, you need to get rid of this one first so that you can break into the bracket. So to get rid of this, you're going to have to divide both hand sides by this 3,200,000 over 7. So dividing both sides by that, 3,200,000 over 7. So this part is going to cancel. And now we just have this over here. Now the bracket is open and we have 1 minus and then 1621 over 1600 to the power of negative 4n. And let's see what this part is going to give us. So we're going to say 200,000 and divided by, I'm going to use the division sign, not a fraction, because this is already a fraction. 3,200,000 over 7. And it gives us a nice simple fraction. It gives us 7 over 16. So 7 over 16 is equal to all of this. Okay, so that's just 7 over 16 that we have here. Okay, then we can go ahead and take the 1 over, and we're going to get, we'll have to say minus 1. So it's the 7 over 16 minus 1 is equal to this. Now remember, there's still a negative in front of this. It's a minus, and we have 1621 over 1600 to the power of negative 4n. So when we take this number and we just say minus 1, it's going to give you negative 9 over 16. So negative 9 over 16 is equal to this. And you can see they're both negative. So we just have to get rid of that negative by dividing both sides or multiplying both sides by negative 1. You can actually just do that. Times negative 1 times negative 1. And to just get rid of that. So on here, just make sure you say times negative 1. Just so that you know you have the positive answer there. So we have 9 over 16 is equal to then the 1621 over 1600 raised to the power of negative 4n. Okay, I think we're at the final stage of this now. So we need to solve for this. To make an exponent a subject, you're going to use log. So we're saying negative 4n, which remember, the negative 4n is really the quarters. We're still going to put it in years. Is equal to log, and the base is this base, the thing carrying the exponent, 1621 over 1600. And then here we're going to have the 9 over 16. So that's why I put it in fractions, because it's just easier to work with like this. And it really helps you just to avoid mistakes. So I'm going to say log. Remember, use this log, not that one, the one with the base. So log, and our base is 1621 over 1600. And then here we're going to have the 9 over 16. Okay, so this calculator is obviously given it in this form. I just have to put it in decimal form. So it says that negative 4n is equal to negative 44.12435, and this keeps going. But we need to find the answer of n. N will tell you the months. Negative 4n, or 4n is just telling you the quarters. So divide both sides by negative 4. So I'm going to take that answer and divide it by negative 4. And n is going to be equal to 11. So round it off to 2 decimals, that's going to be 0.3. Okay, and I'm going to say years here, and I'm going to actually leave the answer like this. I don't want to say 11 years. Technically, it's like 11 years, but I'm just thinking about it like, because it has 0.3, at exactly 11 years, like if you take the number n is equal to 11, right? And you put it into this formula, into the present value formula, and you check, you see that if you put n as 11 here, you're not going to have exactly 200,000. So meaning, technically speaking, the loan is not completely paid off yet. So to be safe, I'm going to just leave the rounded up answer like this and say this is the amount of years it's going to take. Well, honestly, I feel like if you said 11, it will still be fine. So I'm going to take that, and that is the answer for that question. We are on question 7 of this paper, and 7.1 says, a survey conducted in December 2015 determined that 5.7 million South Africans were living with HIV. The researchers used a model of exponential growth, which is A is equal to 1 plus I to the power of n, to predict that there will be 6 million people living with HIV in December 2022. Okay, so we're starting at December 2015 and ending at December 2022. So the question is to calculate as a percentage the annual rate of increase that the researchers used for the 7 years. So firstly, in December 2015, we have 5.7 million people, right? And so these are the people living with HIV. And the researchers, they use this model, and then they find out that it's going to grow. Okay, the amount of people will grow exponentially. So they already gave us the formula. So you can see that this is a growth formula. Okay, it's the compound growth formula we're just going to use. So we know that we started here, meaning that's going to be our principal amount. That is the 5.7 million, which is 5,700,000. And then the A value, they already gave us that. They told us that they predicted that there's going to be 6 million people, okay, at the end of December 2022. So that is the A value. That's how much we end off with, 6 million. And then they also tell us the years, okay, the annual rate of increase that the researchers used for the 7 years. Okay, so they also tell us that. So n is equal to 7. And what they basically want us to find is I. Also, just remember, they say that this is an annual rate increase. So it's not compounded monthly or semi-annually or quarterly or anything like that. So this is all we're really just looking for. So we can substitute it into our formula. So we are saying that we have 6 million is equal to, then we have 5,700,000, and then multiply by 1 plus, and we have our interest, which we don't know yet. It's raised to the power of 7. Okay, so this is really the calculation we're working on here. Okay, we can go ahead and divide both hand sides by this 5.7 million. So this will get rid of a lot of these zeros that we have. So this is how we can do that. So 5.7 million, this is now gone on this side. And then we have this. So you can cancel out your zeros. You see, I see 3 zeros here. And actually, you can look at this as 57. And then all the zeros after it, you can cancel it and then cancel the same amount of zeros here. So I see 5 zeros. I cancel those 5 zeros. Then I will also cancel 5 zeros out here. So it means that we really just have 60 over 57. And we can actually treat it like that. So 60 over 57 is equal to, and what's left is the 1 plus I raised to the power of 7. Now remember, we're just trying to get to the I. So we need to get to the I by getting rid of the 7. The only way to get rid of an exponent of 7 is to find the 7th root of both sides. Okay, so when we find the 7th root, I'm going to leave that like that so that I don't have to work with decimals. What happens here is this breaks open, and now you have a 1 plus I is equal to the 7th root of 60 over 57. And then we have the 1. Okay, that is the last thing stopping us from getting to the I. So we can take that over. So really, I is really equal to, because you're taking the 1 over, so you still have this here, right? It is the 7th root. I don't know how I changed that to a 6. Okay, the 7th root of 60 over 57 and then minus 1. Because remember, that just comes over. So it's still this minus 1. That is what's equal to I. Okay, then we can just find this, put this onto the calculator and find out exactly what this is. So on our calculator, it is 0.0073 5, right? And then also just remember that they specifically asked for the annual rate. So they want it as a rate. Rates are always in percentage. So if it is a percentage, of course. So we're going to go ahead and multiply this by 100. So we're taking everything that we got and we're multiplying it by 100. You could use brackets. You could have also just said aunts multiplied by 100. It would also still work out. Okay, so I'm taking all of that and I'm going to multiply it by 100. And that is the answer that we get. So this is a decimal, but as a percentage, the rate is this. It's going to be, therefore, the rate is 0.74 because that rounds up. The 5 goes over. So it is 0.74% as an annual rate. Okay, so that is the annual rate. So that is it for that question. Moving on to the next question. Okay, so we're on 7.2 and 7.2 says, Shimi invests 4 million rand into an account earning interest of 6% per annum compounded monthly. Okay, so she invests this amount, right? And the interest rate is 6% and it is compounded monthly, okay, per annum, compounded monthly. She withdraws 30,000. So she takes this amount out, withdraws 30,000 per month. Let me just stick to one color. And then they tell us that her first withdrawal is exactly 1 month after she deposited the 4 million. Okay, so how many withdrawals of 30,000 will Shimi be able to make? So I think here, well, something that would be a big hint here is the fact that they are mentioning that her withdrawal is exactly 1 month after. When we hear things like that, 1 month after, it usually has to do with either present value or future value. Now, the thing about it is, if it was future value, for example, future value is for savings. If you're taking money and you're consistently saving money every month or every quarter, then that is future value because you expect your money to continue growing as you are saving more money every month. But you see that in this scenario, that's not really what happened. What happened is she had 4 million and then she invested it into an account that was earning interest of 6%. But then what happens is that she starts to withdraw 30,000 every month. Okay. So instead of it being future value where you're saving money, you're putting money every month, she's actually taking money out every month. Now, what does that actually remind you of? If you said present value, that would be correct. Okay. In this case. So that is really present value because what's going on here is it's kind of like she and the bank are switching places. Normally, with present value, I know that present value is specifically for loans, right? And it's really loan repayment. You're paying back a loan. So the relationship really works like this. It's between you and the bank, right? Someone borrows money, or let's say you borrow money from the bank. And so what happens is the bank had money, but they gave you the money now, right? But the thing is, the money is yours to use for now. Sure, you have to pay it back with interest as well. So you owe a specific amount. So in this case, that's 4 million that you owe. And as you pay back this money, it gets deducted from the amount you owe. Very similar to what's going on in Shami's case. She has money already, right? She's investing it into the bank. So what's actually going on is Shimi is behaving as if she's the bank. She is basically loaning the bank money. Okay, she's taking the money and she's investing it into the bank. So she's giving the bank money. And what she's going to be doing is deducting the 30,000 rand every month. Just like the same way a person would be paying the bank back 30,000, right, every month, then it will make their loan smaller. So I shouldn't even say plus, I should say minus because it's something you owe. And when you pay it back, it gets smaller. You pay back more, it gets smaller. So that's really what's going on here. She has money, but she's going to be withdrawing 30,000 every month. So it's really a situation of not really loans, but we're going to use present value here because that's really how it is working. It's like she and the bank are kind of switching places. She's borrowing money to the bank this time in the form of an investment. Okay, so let's go ahead and see what this is going to look like. So remember that the present value formula is X multiplied by 1 minus 1 plus I raised to the power of negative n and then all over I. And remember, this is in your formula sheet. Okay, so the present value right now would be that amount would be the 4 million. Okay, so that's what we have there. So I only explained it as she being the lender to the bank because it would make more sense in the context of present value. So that is the 4 million over there. And then the X amount. Remember that the X amount is usually the monthly installments that the person is paying, right? So that they can clear off their loan. In this case, so you can actually see the X as the money that you keep on putting in to eventually finish this amount, to eventually finish the loan. Shimi right now took 4 million and put it inside the bank. She's going to keep withdrawing how much every month? 30,000 every month. That is the money that's going to help this money to decrease and eventually become nothing. So we can see that now as our X value. So that is the 30,000 that we have there. Okay, and we're going to take that and say 1 minus 1 plus, and then the interest, it's 6%, but remember it's compounded monthly. So 6% as a percentage, remember that is 6 over 100. And if you simplify that, you will get 0.06. Okay, and then we're going to have to make sure that it also takes that compounding, that monthly compounding. Compounded monthly means you need to divide it by 12 because this is a yearly interest that she's going to gain, right? In the year, she's going to make 6%, but then it has to be broken up into months. So that's why we divide by 12. So we have 0.06 divided by 12. And then we have the to the power of negative n. Now the n is the amount of withdrawals because they're saying how many withdrawals of 30,000 will she be able to make? So will she be able to make until she doesn't have any money left? Kind of like in the situation of a loan. How much payments must you make until you don't owe anything left? Okay, so that is going to be empty, negative n. We don't have anything there yet. And then this still goes over the interest, which is 0.06 over 12. Okay, so this is what we have. And we really have to focus on finding the value of n. Okay, let's go ahead. So we can just work on simplifying things so long so that it's just not too complicated. First of all, I don't like leaving these like that. So what I'll do is I'll put that as 1 plus 0.06 over 12 on the calculator so that I can find out what that is as a fraction. It's just easier to work with as a fraction. Okay, so that amount is actually 201 over 200. So that's actually easier to work with like that. Okay, so when we're actually simplifying, what we're going to do is we can go ahead and divide. Now, because I already wrote this, I'm just going to go ahead and simplify from here already. You see this is your numerator and that's your denominator. Because they're being multiplied, okay, this is being multiplied by that, and they have a denominator, what you can actually do is allow the 30,000 to take that denominator. In other words, I'm saying 30,000 divided by that denominator. So that's really what we're going to find out first of all. And when I do that, I get 6 million. So we have 4 million. Just keep count of the zeros. That's really it there. And then we have 6 million because that's 3 and that's 3. And so our 6. Okay, so 6 million that we have over here. And then we open our bracket and we have 1 minus and then 201 over 200 to the power of negative n, close bracket. Now we can get rid of this 6 million because it is what we need to get rid of to get closer to the negative n. So we can divide both hand sides by that 6 million. So you can just go ahead and say we're going to divide both sides by the 6 million. I'm just going to copy and paste. It's just easier to write like that. So divide and divide. And then let's see what we get. Now, remember how we canceled out when we were dividing in the previous question. The zeros also cancel out. See, we have 3 zeros, 3 zeros, 3 zeros, 3 zeros. So your answer here is just 4 over 6 that you have. And of course, 4 over 6, they both have 2 as a common factor. So divide by 2 is 2, divide by 2 is 3. So that's 2 over 3. So that's what we have there now. 2 over 3, finally. And then over here, your 6 million cancels. Then you're left with 1 minus, and in brackets 201 over 200 raised to the power of negative n. Okay, so at this point, you see, we're trying to solve for this. Do you see that its base has a negative in front of it? What we can do to just make this simpler is take this over so that it becomes positive. So now we have 201 over 200 that is now positive, raised to the power of negative n. That does not change the sign of the negative n. This is an exponent, so it's different. And then you have 1 still on the right-hand side. And then on the left, we're taking that 2 over 3 over. If you say 1 minus 2 over 3, it's like saying 3 over 3 minus 2 over 3, which will give you 1 over 3. So this is what we have. This is our equation. And we need to solve for this. We're really just trying to solve for n. So if you're trying to solve for n in this equation, because n is your exponent, the only way you can solve for n is by using log. Okay, so we're going to say to solve for that negative n, we'll say it's equal to log of the value that we have, which is the 1 over 3, and our base is going to be the base that was carrying the exponents. So our base is still the 201 over 200, and what we are logging is the 1 over 3. Okay, so this is what we have. So we just put that on the calculator and see what we get. Okay, and so negative n is equal to negative 220.27, and I'll just leave it like that because we have to now get rid of the fact that this is negative. It shouldn't be negative, it should be positive. So you can multiply both hand sides by negative 1 to make it positive, or divide both hand sides by negative 1, that's still fine. So it means that n is equal to positive 220.27, right? Now, focus on what the question asked. The question is specifically asking, how many withdrawals of 30,000 Rand would Shimi be able to make? Okay, so if you think about that, this is 220.27. But think about that 0.27. Is that really a full 30,000 Rand? No, it's not a full 30,000 Rand, okay? It's less than 30,000 Rand. That's what that 0.27 stands for. But the 220, that is full 30,000 Rand withdrawals that we have there. So the total number of 30,000 Rand withdrawals would be 220. So I'll say 220 withdrawals. If you like, you can also say of 30,000 Rand. Okay, so that is it for that question. And we move on to the next question. Okay, so 7.2.2 says, how many withdrawals will Shimi be able to make if she changes the amount withdrawn per month to 20,000? Okay, so we're just changing the 30,000 to 20,000. Substantiate your answer. Okay, so we also have to give them some sort of reason, and this is for 3 marks. Remember that this was for 5 marks. So it means don't go stress yourself and start from overs. Just start from a point that you can actually just simplify that. Okay, yeah, we don't really have a choice here. We just have to start from here because at this point we had already substituted the 30,000. So I'm going to take this as it is, and in place of 30,000 I'm just going to replace 20,000 instead. I'm going to replace it with 20,000. So we have this, and that now is going to be 20,000. So let's see what's going to happen here. Okay, so again, we have to divide. So let's take that 20,000 and divide it by the fraction that we have. So we're taking 20,000 and we're saying divided by 0.06 over 12. Okay, that gives us 4 million like we have here. So we have 4 million here is equal to, and we also have 4 million here as well. And then open bracket, what are we left with inside? 1 minus, still the same thing, 201 over 200, and then raised to the power of negative n, close bracket. Okay, if you divide both sides by the 4 million, you're really just going to get 1, because 4 million and 4 million just on both sides really. So those two cancel out, and here we're going to have 1 is equal to, that cancels. It's technically a 1, but it's like 1 times everything here would stay the same. And so you have 1 minus 201 over 200, all raised to the power of negative n. Okay, so we just have to simplify this and try and solve for n here. So in this equation, okay, what we have, you can still do that whole thing of taking that over to make it positive. You'll be left with 201 over 200 raised to the power of negative n is equal to, but now you have still that 1 on the right hand side, and on the left you also have a 1, so we can take that over and that will become minus 1. And so this is 201 over 200 to the power of negative n is equal to 0. Okay, so now looking at that, is equal to 0. Is that even possible? Because what we're actually doing is we're taking, it's kind of like you have a base and you're raising it to an exponent and is equal to 0. That's not possible, okay? Because the thing is, if this is an exponential function that we have, you can't really raise it to any number that is going to give you 0. And the thing about is the base specifically is not 0, okay? The base has a value. Look at the base. The base is 201 over 200, which is a proper fraction, which is a number that is bigger than 1. Our base is greater than 1. So, for example, if you said 2 to the power of a specific number, is it ever going to give you 0? Never. Even if you use a negative number, even if I say 2 to the power of -1, it's going to give me a half, which is a positive number. 2 to the power of -2, it's going to give me 1 over 4, which is also a positive number. Okay, so we're going to have to look at this differently. So let's actually think about how we can solve this, because right now, this would not really have a solution. It doesn't have a solution, but we can also look at it from this angle, because we need to really just tell them the amount of withdrawals. There's definitely an amount of withdrawals. Maybe it's not specifically countable, but there is an amount of withdrawals because we know that there is money that's being taken out every month. Okay, so let's think about it like this. If we were looking at this and really just trying to solve for this exponential equation, right, where we have b to the power of x is equal to 0, that kind of equation would look like this. Because it's b to the power of x and you know that your base is greater than 1, right? It's kind of like numbers like 2 and 3, the numbers that are not fractions in the sense that they are improper fractions like 1 over 2. They're not numbers like that. Okay, so the kind of function that this would form is an exponential function. Okay, I'm trying to solve it looking at it as a graph just to understand what's going on. So if we have a graph that does this, okay, first of all, we know that there's an asymptote at y equals 0. Okay, meaning that y value of 0, this here, okay, this graph will never touch it. Meaning it's never really going to have a value of 0. Okay, but we can also look at the fact that, please also remember the function we're looking at is this one. I'm just actually building this up just because it is an exponential function and I'm just trying to show you what that actually looks like. So naturally an exponential function that has b to the power of x is equal to 0, where b is greater than 0, it would normally just increase like that. Okay, so with this function, what we can do here is make it look like this one. Okay, we already have our b value being greater than 0. That's great. But you see that next to n, they multiply by -1. We can also do that here. However, that's going to cause something to happen with our graph. If you multiply your x values by -1, what you're actually doing is you are actually reflecting this graph in the y-axis or through the y-axis. That's what you're doing. Okay, so if we are reflecting that in the y-axis, it's just going to form a mirror image through the y-axis like that. So it's going to really just look like this. So this is actually our graph. That's what our graph should look like. Okay, b to the power of -x. And then it fits this one. It really just looks like that. So we're trying to find out what our solution should be if we're trying to make this equal to 0. So if we were trying to make it equal to 0, this is what would happen. Remember, being equal to 0, that refers to the y values. Okay, I could say try to make this equal to 1. Then I'll just look for all the places on this graph where it has a y value of 1. And then I'll answer them like that. I'll say the x values, for example, let's say 5. Okay, it's not actually 5, but that's just an example. And in this case, we're really just trying to find out where's the y value equal to 0. Now, we can see that it actually doesn't end up becoming 0. However, do you see that if you are looking for the places that are at least close to 0, that have y values that are close to 0, okay, you look at it like this. You see, if you look on top, these values are positive. These values are not close to 0. We're trying to look for y values that are close to 0. If you keep going down, okay, look at the graph here. For example, let's say here. Look at where this graph is. Its x value is here, okay? And as we get closer to the y value of 0, look at where the graph heads towards, okay? Look at the x values of this graph. As you get closer and closer to a y value of 0, your graph, your x values of your graph are moving towards the right-hand side. Now, we know because it's an exponential function and there is an asymptote here, it will never actually become 0. However, as we approach 0, okay, our x values move closer and closer to positive infinity. Do you see that? Okay, so with that, the way we can answer this question really is like this. For this expression, I change that to 0. For this expression to be equal to 0, you need to take n values, okay, that move towards positive infinity. So for this equation, okay, not even just this one to be equal to 0, our n value needs to move closer and closer to positive infinity, or should be positive infinity, should be heading towards positive infinity, because that's the only value that helps us move towards a y value that is at least close to 0. It may not reach 0, but it's close to 0. So in a nutshell, I'll really just say that n, the answer for n in the context of this question, because they specifically want us to tell them the amount of withdrawals per month. I'll tell them that there is an infinite amount of withdrawals that you can make, okay, in this. Okay, so there is an infinite amount of withdrawals of 20,000 Rand that Shimmy can make. And I actually want to show you how this is going to work out if we're looking at it like this. So remember that Shimmy had 4 million Rand, right? So 4 million, that's how much she starts off with. And then she invests it into an account. And she's going to be withdrawing 20,000, okay, in this 7.2.2. She's going to be withdrawing that amount. So let's look at what happens. You see, this money is being put in here, invested at a rate of 6%, okay, per annum, but compounded monthly. So we still have to divide it by 12. So what happens is when the money gets invested, 1 month later, she's going to withdraw 30,000. But this 4 million will not be 4 million anymore. Remember, it's going to gain interest. So because it's going to gain interest, we're going to take that 4 million and we would multiply it by the amount of interest it's going to make. And of course, remember that the 4 million and the interest is going to be here. They're both going to be here. So how I'll look at that is by saying 1 plus, okay, 0.06 over 12. The reason why is because I'm saying that the 4 million and the interest of 4 million, okay, 6% is also going to be there. So if you did that calculation, we can go ahead and put that down and see what that gives us. And look at how much will be in her account. The amount in her account is 4 million and 20,000 Rand. And then what happens is when it grows, she's going to withdraw 20,000. So she's going to take out 20,000 and then see what happens now. What is left in the account after she removes 20,000? The 4 million again. And then what's going to happen in the next payment? It's going to grow. That 4 million that she left in that account will grow again at the same rate. So it's going to grow again at 6% again. And so it's really just going to become that 4 million and 20,000 like it did initially. You see, when it grew the first month, it became that. We ended up with 4 million again after her withdrawal. Then it's going to grow again at 4 million. It grows again to this. And then she's going to withdraw again 20,000. And then she'll be left with 4 million again. And then in the next month, it's going to grow again to 4 million and 20,000. And then she's going to withdraw. And that's why it's an infinite amount. Because at this rate, okay, if you're withdrawing exactly 20,000, that's what's going to happen in a theory sense. But in real life, they'll probably just calculate this a little differently. They may not maybe use something like present value. Or they may even just make adjustments probably to either the interest rate or the amount that is being withdrawn. Okay, so that is the reason why we ended up with infinity. There's an infinite amount of withdrawals, and I hope you guys could understand that with the way this kept on going. Okay, so that is it for 7.2.2. So we're done with that. And then we finally move on to the last question in question 7. Okay, so 7.3 says, Estrid opens a savings account with a single deposit of 1,000 Rand on the 1st of April 2022. She then makes 18 monthly deposits at the end of every month. So her first payment is made on the 30th of April, You can see on the first, she opened the account and put 1,000. Then she makes a first deposit at the end of the month in that same month. And then her last payment on the 30th of September 2023. That's when she makes the last payment. So the account earns an interest of 15% per annum compounded monthly. We have to determine the amount that should be, I need to highlight that as well, okay? Compounded monthly. Determine the amount that should be in her savings account immediately after her last deposit is made. That is specifically on the 30th of September 2023. Okay, let's go ahead and create a timeline so that we can understand what's going on here. I'm not saying this is specifically timelines. I'm just creating a timeline just so that I can see what is going on. So the first thing that happens is that Estrid opens this account, right? And the account has 1,000 Rand. She opens it with 1,000 Rand. So she doesn't just go and open an account. She puts 1,000 immediately. She opens it. Okay. And then she starts to make deposits. She makes 18 deposits of 700 Rand in total every end of the month, right? So the first deposit that she makes, they mentioned, was on the 30th. And I should actually be writing this here. So 1,000 first, and that's on the 1st of April, specifically 2022. Then the first deposit was on the 30th of April, 2022, and that was 700 Rand. And then she continues to make deposits. So after April, May, okay, she's going to also make a deposit there as well. And she basically does this all the way until the 30th of September. That's the last time she makes a deposit of 700 again. So 30th of September. But now we don't have to go ahead and start 2023, of course. We don't have to start counting how many deposits she made because they told us that. They told us that she made 18 deposits in total. So from here, this 700 Rand deposit, okay, she made 18 700 Rand deposits. Okay, so that's how much she deposited. So with this, the question is how much is going to be in her account immediately after this last deposit. So looking at this, it actually follows the basic order of future value calculations because there's no loan happening here. She's depositing money. She's taking a specific amount of money and it's the same amount throughout, and she's consistently depositing that amount every end of the month. So this is future value, okay? So she's saving that money. The only thing that you need to consider is this 1,000. This 1,000 is not part of these consecutive 700 Rand deposits. This one, she puts it immediately she opens the account. So what we can do is actually look at the 1,000 as a separate investment. So that 1,000 Rand, how long will it stay in her account? Well, you're going to have to think about how long this account lasted. The last deposit happens here, right? 700 Rand, it's at the 30th of September. That's the last deposit. So if you count how long that would be, from here, okay, from April to September, that is 18 months. And the reason I'm saying it has to be 18 months is because we have 18 deposits every end of the month. So meaning a deposit in April, a deposit in May, and it keeps going until the next year, September 2023. So that is 18 months that this account has been active. Okay, so that is going to gain interest for, see, 1 and 2 and 3, all the way to 18, and it's not going to go past this because this is where the last deposit is made. So I'm going to calculate that as a separate investment, and it's going to grow for 18 months. Then the other thing we're going to have to think about is we're going to have to think about this as a future value investment because she's taken an amount of money and she keeps depositing that same amount every month. Do you see that she opened the account on the 1st but only started this consecutive deposits of 700 Rand 1 month after the account was created? So we can actually look at it separately. We can start with the 1,000 Rand and see where this went. So we're going to use the compound interest growth formula for the 1,000 because it was not consecutive deposits. It was just one deposit that she made of this. So that is A is equal to, and we'll say P, of course. Now the principal amount is the amount you invest. That will be the 1,000. That's how much she invested initially. We're going to grow that amount, of course. And it's 1 plus our interest rate. They already told us that. It is 15%, so 0.15 compounded monthly over 12. Okay, raised to the power of, and remember, how long does this 1,000 Rand stay in this account? It stays for 18 months. So it goes to the power of 18. So we'll calculate that one separately and then the other one separately as well. Okay, so I see the amount, but the thing is, because they are decimals, I'll hold on to that and we'll add it afterwards. Okay, so we can just leave it like that so long. Then we have to calculate the 700 rands. Okay, so this one is the one that we're going to use future value for, because that is the one where she doesn't deposit just one 700, she consecutively deposits 700 rand 18 times. Okay, so each month, 18 months. So for that, we're going to use the future value formula, which is x, and then remember, this is in your formula sheet. We have 1 plus I raised to the power of n minus 1 all over I. So we're going to go ahead and calculate this. So our future value should be equal to, our X amount is that 700, because that is your monthly deposits. Then we have 1 plus our interest is, we have our interest over here, 0.15 over 12 raised to the power of how many deposits was made? 18 deposits, okay, minus 1, and then all over the interest, which is 0.15 over 12. Okay, and really what happens is that these two amounts get added. So I'll really just add them together. I'll add the amount that is in her account, because really the question at the end just says you just need to determine the amount that should be left in her savings account. So I'll just say amount left in account. So that would be the accumulated amount of the 1,000 being invested plus the future value. So we can really just add those together. Okay, so yeah, I actually wanted to do it as one calculation because I knew that decimals were going to happen either ways. So we can actually do that. So you just have to be very careful on your calculator to just not make any errors. So I'm going to add that whole thing there. Okay, so just be careful not to make any mistakes with this. So let's go ahead and add that, and then we'll see what we finally get as our final answer. But if you just round it off to like at least 4 decimals and then 4 decimals and add it, it should be fine as well. So you can also do that. You don't have to be worried about that. Okay, so when I add both of them, I get the final answer being 15,282 points, and this is 0.91 cents. And that is our final answer. Okay, so now we are on question 6. Question 6 is on financial math. So 6.1.1, of course, but 6.1 says Patrick deposits an amount of deposits P. Deposits an amount of 18,500 into an account earning R% interest per annum compounded monthly. After 6 months, his balance was 19,319 Rand and 48 cents. So the first question is we need to find the value of R. Okay, so just look at that question and ask yourself, was that compound interest growth? Was it decay? What was it? His compound interest growth, because he deposited money, right? Deposited, that's a P value, starting value, and his balance is now way bigger. So the money grew. He deposited, it's growing. So what we're going to do is we're just going to use, I like to use this acronym, PAIN, PAIN, just so that everything is sorted out already. P is our principal amount, is 18,500. 500. A is 19,319.48. The interest is what we don't know. We need to find that rate. And N is just the number of payments. Well, it's 6 months, so we can just say 6, and we don't have to multiply by 12 because it's already in months. Now, with that being said, I have to explain what we're going to do here. By the I, you need to remember that whatever the interest is, we need to put that over 12, okay, because it is compounded monthly. I'm just not going to multiply that by 12 because it's already in months, 6 months. So this is what we're going to have. We have A is equal to P bracket 1 plus I raised to the power of N. So the A is the 19,319 Rand and 48 cents. And then we have, it's equal to Okay, so I'll just put it on the side there. So I'm saying this amount, so just substitute everything in. A, which is this, is equal to the p-value 18,500 multiplied by 1 plus I, and our interest is just I, over 12 raised to the power of 6. And we just have to solve for I, and then of course put it as a rate, not just as a decimal. Okay, let's go ahead and do that. So in this equation, how do we get I on its own? Well, the first problem that we have is this 18,500. It's the first thing blocking us from getting to the I. So we need to divide both sides by 18,500, but I'm not going to find the answer because I don't like working with decimals. So 18,500, I'll leave it like that. So here this cancels, and here I'm just going to rewrite this, really copy and paste, exactly as it is like that. And I have here, since that cancelled out, it's equal to 1 plus the interest over 12 raised to the power of 6. Okay, now what's your next problem? What is stopping you from getting to this I? It's the 6. So we're going to find the 6th root of both sides. Okay, this is financial math. Interest is never negative. You don't have to think about positive and negative. So when that happens, what happens here is they cancel each other because they're the inverse of each other. And this is, I'm just going to leave it like that. I don't want to work with decimals, so leaving it like that. Okay, so this is what we have right now. And then we still have here, when that breaks open, we have 1 plus the interest over 12. Okay, and then now that we have the interest over 12, we're just going to say, take the 1 over now, because that's what's stopping you from getting to the I. And so we're just going to have this exact same thing, but the 1 is coming over and becoming a minus 1 is equal to I over 12. Lastly, the 12 is in the way. We have to get rid of it. Since it's saying divided by 12, you would multiply by 12 to get rid of it on both sides. Okay, so our interest is equal to all of this, 12 multiplied by the 6th root of that 19,000 and all of that. Okay, and when you substitute that onto the calculator, the interest I get is I is equal to 0.087000, and this just keeps going. But then remember, you need to answer them as a rate. When they ask the question as a rate, they want like 12% or 3.5%. So you need to multiply it by 100. So take all of that and just multiply by 100, and that's going to be your percentage. Your rate, right, or R, is 8.7% because you just have zeros all through there. So that is your rate. Okay, so that is the first question, and the next question is this. 6.1.2, calculate the effective interest rate. So nominal and effective interest rate. The nominal interest rate is really the interest rate that the bank quotes you with whatever compounding that you have. And then the effective interest rate is that converted into kind of a yearly interest rate. It's just converted into a yearly interest rate. And so the effective interest rate is, that formula works like this. You say 1 plus I effective is equal to 1 plus I nominal divided by, I guess you can say n to the power of n. Okay, so whatever compounding that we have, we'll put that there. And so we'll find the effective interest rate. In this one, it is 1 plus, we have I effective, and this is equal to 1 plus the nominal interest rate is whatever was in a different compounding. In this one, it was this interest rate that we found 8.7%, but you have to put it as a decimal. So we will put it as 8.7%, right? Over whatever compounding it was in. It was compounded monthly, so we have to put it over 12 raised to the power of what? 12. Okay, this is not considering any 6 months. We're just working with the actual interest rate and converting it into an effective. Okay, so I'm used to putting brackets here. It's not really necessary because, okay, it's raised to the power of 1 really. And so now to find that effective interest rate, you see that the 1 is in the way, so you need to take it over. So it really just means that I effective is equal to everything that we still had here And all that happens is that 1 is going to come over and become a -1. And that's going to give you your effective interest rate. Okay, so this is what I get. I get 0.09055, but then I'm just going to turn it into a rate by multiplying it by 100. And so my effective or yearly interest rate is actually just going to be times 100. It's just 9.055, which if you round up to 2 decimal places is 0.6. Okay, because it rounds up. That 5 is going to round up. So 9.06%, and this is a yearly interest rate. Okay, so that is 6.1 done. And now we move on to the next part. Okay, so the next part says this. I probably need to just make the screen a little bigger. Okay, so it says, Kuda bought a laptop for 10,000 Rand on the 31st of January 2019. He will replace it with a new one in 5 years' time on the 31st of January 2024. So this is 5 years exactly. It's 31st of January 2019 to 2024. That's exactly 5 years. And we have the value of the old laptop depreciates annually at a rate of 20% per annum according to the straight line method. After how much years will the laptop have a value of 0? As you can see, something is depreciating, but it's depreciating on the straight line method. So what is the formula for a straight line depreciation? It is A is equal to P bracket 1 minus I multiplied by N. Okay, because this is straight line, it's not compound, and it's also depreciating. So we just need to know what all these values are. First of all, P is always the starting value, whatever you start off with. Okay, P is not just always, whatever is the smallest number. No. Okay, it's whatever you start off with. Whether it's going to be the smaller or the bigger number depends on whether you are depreciating or this is an investment, something that will appreciate. Okay, so what we're just going to do is the value of P is going to be whatever money he starts off with. So Kuda starts off with 10,000 Rand. That's what the laptop costs at first. So that's going to be P. So that's what I'm putting in place of P, 10,000 Rand, right? And then after 5 years, so we also know what N is. Really, we also know what R is, okay? And we know what A is as well. They said the laptop is going to have a value of 0 Rand. That's how much he ends up with. So the starting value is 10,000, but the ending value is 0 Rands. Okay, so we have 1 minus the interest is 20% on a straight line method, so it's not compounded. So 0.20, then multiplied by N. Okay, it's multiplied by N because the question is how many years? Okay, so we need to find out the time period. So multiplied by N, and I'll just say times N like that. So we just have to solve for N in this straight line equation. It's a linear equation. How do you get to N? Well, first you have to get rid of the 10,000, and you can get rid of it by dividing both sides by 10,000 Rand. If you divide by 10,000, 0 divided by 10,000 is 0, and so that cancels, and you're left with 1 minus 0.20 N. Then I need to solve for N, so I'm going to rather take this over to this side since it's negative, so it becomes positive 0.20 N is equal to, and I still have the 1. Then I need to solve for N. So to solve for N, I'm just going to divide both sides by 0.20. And so N is finally equal to whatever 1 divided by 0.20 is. And 1 divided by 0.20 is just 5. So how much years is it going to take to become nothing? 5 years. Okay. So that is that question. Moving on to the next question. Okay, so 6.2.2 says, Kuda will buy a laptop that costs 20,000 Rand. In order to cover the cost price, he made his first monthly deposit into a savings account on the 28th of February 2019. He will make his 60th monthly deposit on the 31st of January 2024. The savings account pays interest at 8.7% per annum compounded monthly. Okay. And they also say that calculate Kuda's monthly deposit into this account. So, with the way everything looks, they're really not trying to complicate things. They're actually being very straightforward with this question. They even saying 60th monthly deposit, telling you already how much deposits we're going to have. So because Kuda is trying to save money, and we can see that he's trying to buy a laptop that costs 20,000 Rand, anytime you're working with a savings plan, this is going to be future value. Okay, so Kuda is saving money. So the future value formula says it's future value is equal to X and then open bracket 1 plus I raised to the power of n minus 1 close bracket over I. The future value, let's think about what that is. That's the amounts that he's supposed to have in future. Does he have the 20,000 now? No, that's how much the laptop costs. That's how much he wants to end up with in future. So that's your cost. That's your future value, 20,000 Rand. Then the X, do we have that? Do we know how much Kuda is going to pay monthly? No, because they asked us to calculate Kuda's monthly deposit. That's going to be X. Okay, Kuda's monthly deposit is X. So we're leaving X open and then open bracket 1 plus the interest rate is 8.7% per annum compounded monthly. So you need to put that in decimal form, 0.087 over 12. Raised to the power of how much deposits? N is always for the amount of deposits. Well, you see, they already told you the 60th monthly deposit. He will make his 60th monthly deposit on this day. That's the last deposit. So the deposit is 60 deposits minus 1 and then all over that same interest. So 0.087 over 12. And now we just have to solve for X. So this is a common one where you have to solve for X because it's the monthly deposit. A way that you can do this is imagine all of this is just one single number and you have X next to it. In order to solve for X, you would just say simply all of this divided by that number that is there. And what you do on this side, you must do on this side. So you would say 20,000 divided by that number that is there. Okay? So your equation will just say X is equal to 20,000 divided by everything here. Okay? So it will look like this. And this will finally be equal to 267 Rand and 26 cents. That's how much his monthly deposits will be so that he can end up with that 20,000 after 5 years. Okay, so that is it for that question. Then we move on to the last question in question 6, which is 6.3. So question 6.3 says, Tino wins a jackpot of 1,600,000 Rand. So that's how much he wins. He invests all his winnings in a fund that earns an interest of 11.2% per annum compounded monthly, and then he withdraws 20,000 from the fund at the end of each month. His first withdrawal is exactly 1 month after his initial investment. That's normal. And so the question is, how many withdrawals of 20,000 Rand will Tino be able to make from this fund? So now do you see what's going on? Money keeps leaving. It's still a loan. The only difference is that Tino is not loaning from the bank. The bank is basically loaning from Tino because he's giving them his money and he's going to be receiving from them 20,000 Rand just because of the interest that is applied to that loan. Okay, so this is the situation. This is one of those situations where a person is borrowing to the bank. Okay, the people who invest money, it's kind of like borrowing to the bank. You're giving the bank your money for a period of time. It earns interest, and sometimes you can actually just ask them to give you a specific monthly amount. Okay, so a monthly withdrawal really. Okay, so it's still a loan, just not Tino. Tino is not loaning from the bank. It's the other way around really. And so we need to find out how much withdrawals of 20,000 Rand can Tino receive. That's a very important question to really focus on. How much withdrawals? They're not saying how long will it take his money to finish. How much withdrawals? So let's think about what present value looks like. The present value formula is X bracket 1 minus 1 plus I raised to the power of negative n, close bracket, over I. Okay, so this is what we have. The present value, the money that the bank currently will owe Tino if he gives them the money, if he invests the money, is that 1,600,000 rand. Then the X value is really the amounts that Tino is going to allow to withdraw every month, which is 20,000 rand, right? Then the interest is compounded monthly, 0.112, so that's 11% over 12. And then finally, we also know now we need to find N. So you see N always stands for the number of years. If you don't touch N, if you don't do anything to N, it will just give you the number of installments, right? It's going to tell you how much installments were made. So you leave it like that. Don't touch it. Just leave it like that. We're not going to divide. So I will leave N like this and just simplify this. Okay, so we're just going to have 1,600,000 is equal to, and the X value is 20,000 rand. Open bracket, 1 minus 1 plus 0.112 over 12 raised to the power of negative how much? We don't know that yet. So negative n, close bracket. And then we have all over that interest, which is 0.112 over 12. Let's be careful. Okay, so when we are at this point, we just need to find a way to get to the n, or the negative n really. So we can get to it, first of all, by getting rid of things that are stopping us from getting to the end. The first thing I see that is stopping us is this. Okay, so since this entire expression is being divided by this, to get rid of it, I can just multiply both sides by it, 0.112 over 12, and do the same on this side, 0.112 over 12, right? And now this is gone on this side, and what I will be left with here is I'll just calculate that. It will probably be a fraction. And as a fraction, what I got was 44800 over 3, right? For that part. But now this is now gone. All I have left here is the 20,000 still being multiplied by 1 minus 1 plus. Now, because this is a fraction, this gives me an opportunity to just find out exactly what this is. So I want to find out what 1 plus 0.112 over 12 is, and keep that answer as a fraction. That's what I'm just trying to do here. So let me see what that gives us. So as a fraction, that is equal to this. So it is 757 over 750 raised to the power of negative n, and close the bracket. Okay, so there's nothing we're dividing by now. Now the next problem, stopping us from getting to that negative n, would be the 20,000. So you'd have to divide both sides of the equation by 20,000. So divide by 20,000. Okay, so this number divided by 20,000. I suggest you actually use the division button. So like that, over 3, then say divided by that 20,000. Okay, also gives us a fraction. That's good. So we're just going to use it as fractions because it's easier to keep track of what it is rather than decimals. So it's equal to, and this cancels now, and you're left with 1 minus 757 over 750 raised to the power of negative n. Then I can take the 1 over. So in other words, I have this answer, and 1 is coming over, becomes minus 1. And now this is what I have. I have negative 19 over 75 is equal to, you see, you still have a negative here in front of this. And we have 757 over 750 to the power of negative n. Okay, they're both negative. You can get rid of the negative by multiplying both sides by negative 1. Okay, and that will cancel out the negative. So I'm just going to say it as I'm canceling out the negative. Not that it wasn't there, it was there, but I'm just canceling out. Okay, so gone. And of course, I would just take this and still multiply it by negative 1 so that it is positive, and I am using a positive number now. Okay, so since now what we have is 19 over 75 is equal to this over to the power of negative n, we need to solve for negative n. So to solve for an exponent, you have to use log. So I'm saying negative n is equal to log, and I'm going to write down my base. My base is whatever is carrying the exponent, which is this. So my base is 757 over 750, and then the number that it's equal to is the number I write here, 19 over 75. Okay, so these are all nice looking numbers that I can use. So I'm just going to use them like that. So on the calculator, go to log, right, with the one with the base, and you're saying 757 over 750, and then here you're going to put your 19 over 75, and this is what it gives us. Negative n is equal to negative 147.7978, and this keeps going. I'm just going to go ahead and divide both sides by negative 1, or you can say multiply by negative 1 on both sides. And so I'm saying that n, positive n, is equal to, so times negative 1, of course, is just going to be a positive of whatever you had before. So positive 147.7978. Now let's go back to the question so we know exactly what to tell them. The question was, right, how many withdrawals of 20,000 will Tino be able to make from this fund? This is telling you the amount of withdrawals. This was compounded monthly, okay? So this is the amount of months in total. In other words, the amount of withdrawals that is going to make. I'm not going to convert it into years. I'm going to leave it like this. But if you have to think about it, the total amount of 20,000 that he's going to be able to withdraw is 147. You cannot round off to 148 in this one, because 148 would mean that he can make a complete 148 withdrawals of 20,000, but we know you can't. He can only make 147. This is not a complete 20,000 that he would make. It's a 0.79. It's almost 20,000, but it's not exactly. So how much withdrawals of 20,000? He will make 147 withdrawals. Okay, so that's going to be our answer there. Hi grade 12s, and welcome to question 7 of the May to June 2024 paper. So we're on 7.1, and 7.1 says, 6 years ago, Tabo bought a phone for 13,000 Rand. The value of the phone depreciated annually according to the reducing balance method. The value of the phone is now 8,337 Rand point 75 cents. Calculate the annual rate of depreciation. Okay, so you see they've already used a lot of keywords here. They've said that it's reducing balance, and they have also told us that this is depreciation. We're taking a phone that costs 13,000, that's how much we start with, and it depreciates to 8,000, okay? So we know this is a form of depreciation, but which type? Is it simple decay or compound decay? It would be compound decay. And the reason why is because they said reducing balance, okay? Reducing balance always stands for compound. So our equation would be A is equal to P bracket 1 minus I raised to the power of N. Okay, so that would be our equation. Okay, so let's think about what all of these are. So A, P, I, and N. Remember that they said that 6 years ago, right? They already gave us the amount of years, so we already know N is 6. 6 years ago, Tabo bought a phone for 13,000. So this is how much he starts off with this phone. Your starting amount is always your principal value. So that's the 13,000 that we have there. And then the amount that you end off with is your A value, and that's 8,337.75. So you see the difference with this one. With this one, with depreciation, you will notice that your starting value would be more than your ending value. And then, of course, we are actually looking for I, which they tell us is an annual rate of depreciation. So it's not compounded in any way. It's just an annual depreciation. Okay, so let's substitute. We're going to go ahead and say this is 8,337.75 is equal to 13,000, and then 1 minus our interest, we're looking for that, raised to the power of 6. Okay, so now that we have this equation, we have to get to I. Ask yourself, what is stopping me from getting to I right now? So I know there is a 6, yes, but that's not really the first problem. The first problem would be this 13,000 over here. This has to leave. Now, because 13,000 is being multiplied to this bracket, to get it out, we would have to divide by 13,000. So because this is an equation, what you do on the one side, you must also do on the other side as well. So this is what we have. Now what I'm going to do is I'm not going to calculate this. I'm going to keep writing it like that so that I don't have to work with decimals. Okay, I want to avoid working with decimals. So that's what we have there is equal to, and so you see these would cancel and you'll be left with the 1 minus I raised to the power of 6. So you still want to get to the I. What is stopping you now from getting to the I? Now that would be the 6. So it's being raised to the power of 6. So to reverse that, or the opposite of that, would be to 6th root both sides. So we're just going to say the 6th root of this side and the 6th root of that side, of course, because it's an equation. So that 6th root and the power of 6 would cancel with each other. And then you just have 1 minus I. And then over here, you just have everything here. Okay, so here is something that we can do. I want you to notice that your I is actually negative. So what you can do to make this easier is take the I over to make it positive first of all. Then on the right hand side, you're left with a 1. And then what we're going to do is take this over, and when you take it over, it becomes negative. So it's negative of the same number. Okay, so this is what we have. And then you can just put that on the calculator and it will give you your decimal answer. And so this is what we get. We get I is equal to 0.071352, right? But you need to multiply this by 100 because remember that they want the annual rate, okay? Rates are always in percentages. So we're going to say I is equal to, and just take your answer. So just say say equal to, then multiply by 100. Okay, so you see that it's 7.14%. And that is the annual rate of depreciation. Okay, moving on to the next question. Okay, 7.2 says, Eric and Tandy need to save 80,000 Rand to go on a holiday at the end of December 2027. So they tell us that Tandy decides that she will start saving at the end of January 2025. We'll keep that in mind. So Tandy's going to start at the end of January 2025. She will make 36 monthly deposits. Okay, they're making our lives easier. Make 36 monthly deposits into a savings account that pays interest at 8.6% per annum compounded monthly. Okay, so it's also compounded monthly. Let's just keep that in mind. The deposit will be at the end of each month. And that's fine. Then they tell us about Eric. Eric calculates that if he makes 48 deposits of 1,402.31 Rand, starting at the end of January 2024. Okay, she's starting 2025, he's starting 2024. He will have enough money to go on holiday. He will make his deposits into a savings account at the end of each month. Okay, that's just the same as her. The savings account pays interest at 8.6% per annum, compounded monthly. So same thing. So the question is, calculate the difference between the amount that Eric and Tandy will deposit into their respective savings accounts over the given period. So we're looking at the difference, meaning we're going to calculate how much they're going to deposit, not really their future value. We know how much they want to save. They want to save 80,000, but we're going to look at what they're each going to deposit, because just because you want to save 80,000, it doesn't mean that as a whole you would have deposited 80,000. Okay, future value has interest added, so you would definitely deposit less than 80,000, and then the interest will cover the rest. So we're really just going to work on this. We're going to work on both of their situations separately. So this will be Tandy, and let's work on Eric on this side. Okay, so let me just divide these. Okay, so let's start over with Tandy. We know that this is a savings plan. So we're going to, of course, use future value. Okay, we're going to use the future value formula. And it's best to actually just put that formula down so that you know what you're working with. So this is the future value formula. And we're just going to look at everything we need to have in these. So remember, the main goal is just to find out how much they're each going to deposit at the end of, this period that they have. So let's look at it like this. With Thandi, they said that Thandi starts, she's going to make 36 monthly deposits, and she starts at the end of January 2025, okay, which makes sense. So January 2025, and we know that she needs to end in December 2027. Okay, so as you can see, December 2027, if you calculate that, that is actually 36 months, because from January 2025 to December 2025, that's 12 months. Okay, so January to December of that, and then from, of course, January the next year to December of that same year would be 12 months, and then of course January 2027 to December 2027 would be 12 months again. So that is a total of 36. They made that easy for us so we don't have to overthink it. So we know it's 36 months, but then the thing about this is that we just need to look at a specific value. We need to know how much each of them are going to deposit as a whole. What tells you the amount that you're depositing is X. So let's actually make sure that we have X in each scenario. So in the first scenario, do we have the value of X, the amount that she keeps putting in to save every month at the end of the month, of course? Do we have that? No, we don't have that. They only told us about when she's going to start, the 36 months, that it was compounded monthly. They also told us the interest, but they didn't tell us anything about how much she's going to be paying every month. So clearly, we have to find that out with Thandi. So let's go ahead and do that. We're going to use the future value formula. So with the future value formula, we need the future value, which we know is 80,000. That's how much she expects to have in future. So 80,000 is equal to, we don't have her X amount, so we're going to hold on to that. And then we have bracket 1 plus, and our interest there is 8.6 per annum compounded monthly. Remember that 8.6% as a decimal is 0.086. Okay, so you just put a 0 in front of 8 because it's a single number. 8.6% as a decimal, that is 0.086 over 12. And then we're going to take that and raise it to the power of, now the N stands for the amount of deposits they're going to make. So the amount of deposits that she makes, since it's 36 monthly deposits, is 36, right? So we're going to put to the power of 36, then minus 1, all over our interest, which is of course 0.086 over 12. Okay, so we just need to solve for X. I want you to see it like this. You see all of these? They're just numbers. When you simplify them, it's just going to be a number. So what we need to do is get to the X. This number, okay, including the denominator, they're being multiplied, okay, to the X. So to get rid of it, you need to divide both sides by this number. So we're just taking this number and dividing by that on this side and on this side. So as you can see on this side, they would cancel. And then you would be left with, on this side, the 80,000 divided by that number. Okay, so it looks like this. And then when we put it on the calculator, this is what we're going to have. So on the calculator, as you can see, the answer that we get for X is 1,955.78 cents, rounded off to 2 decimal places. So now we have Thandi's X amount. Okay, and I'm not going to go looking for anything else because that's all they asked for. That's really what we're looking for. How much she's going to deposit as a whole. Okay, this is what she's going to put per month. Okay, so let's hold on to that. Then let's look at Eric. So with Eric, they tell us that Eric calculates that if he makes 48 deposits of this amount, okay, starting at the end of January 2024. So you see that with Eric, they already told us how much he's going to deposit each month. So that is the X amount. So Eric's X amount, we don't have to find that. That is 1,402 Rand 31 cents. Okay, so now that we have both their monthly deposits, we're going to find out how much they're going to deposit as a whole, individually. Okay, so Thandi is depositing for how long? For 36 months. So out of her pocket, what she's going to have paid, what she's going to have taken out of her pocket would be, we would take the amount that she's paying monthly. And how many months does she pay this for? She pays this for a total of 36 months. So we're going to multiply it by 36. And that's going to tell us the total amount that Thandi ended up paying. And when I calculate that, I get 70,408.08 cents. Okay, so that's how much Thandi pays as a whole. Now let's also go ahead and see Eric. How much does Eric pay? Well, this is the amount that he's paying per month. So we just have to take this and calculate, or not really calculate, they gave us that already, and just multiply by the amount of months that he pays this for. Well, Eric paid this for 48 months, okay? He made 48 deposits. So clearly he made more than her. He started earlier than her. And so let's see how much Eric pays. Okay, so this is how much he is going to pay. So that is 67,310.88 cents. Okay, so very interesting. Thandi started in 2025. Eric started in 2024. Okay, so he started earlier than her, and then he ends up depositing less than her when we look at it as a whole. Okay, that's obviously because the more time you spend to save, the more interest it's going to build up and help you reach your goal faster. So he wouldn't have needed to pay as much as her to reach the 80,000 because he started earlier than her. He started in January 2024. Okay, so that makes sense. But the question was, they want us to calculate the difference between the total amount that Eric and Thandi will deposit into their respective savings account over the given period. So just the difference. So as you can see, Thandi pays more. The difference between the amounts they pay is that 70,408.08 minus Eric's 67,310.88 cents. Okay, and the difference that we have there is 3,097.20 cents, really, okay? So that is the difference. As you can see, Thandi ends up paying this amount more than Eric because she decided to start a little later. Okay, so that is that question 7.2. And then we move on to the last question in financial maths, 7.3. Okay, so we're finally on 7.3, and 7.3 says, Lesibana was granted a loan of 225,000 Rand. The rate of interest for the loan is 9% per annum compounded monthly. Lesibana will make monthly payments of 5,500 starting exactly 4 months after the loan was granted. How many payments will Lesibana make to settle the loan? Okay, so loans, so already speaking about present value. So we just keep that in mind. It's going to be present value. And they tell us the loan amount already. So let me put down the present value formula so that we have it and we know what we're supposed to really look for. Okay, so this is the present value formula. And since they tell us this was the loan amount, right? That's going to be your present value. So present value is the 225,000 Rand. And then we have the rate of interest of the loan is 9% per annum compounded monthly. So we can already write that. I is going to be 9% is 0.09. Compounded monthly is over 12. And then they also tell us that Lesibana will make monthly payments of 5,500. So we have X is equal to 5,500 that we have there as well, because that's your monthly payments or your regular payments, right? Per month or per annum or every 6 months or quarters. So we have that, and it is monthly payments. Then they say starting exactly 4 months. Okay, so that is a very big thing that we need to consider now. So starting exactly 4 months after the loan was granted. The question is, how many payments will Lesibana make to settle the loan? Okay, so we know we need to tell them how many payments at the end of the day. But here's this one thing we need to consider before even using this formula now. You see, these payments start 4 months after the loan was granted. So this is how present value and even future value works. This formula is adjusted so that when you are granted the loan, okay, so this is when you got the loan of 225,000, you are supposed to pay this loan. So here's the end period, whatever that is. Because this is a monthly payment, right? You're supposed to start paying this payment 1 month after. And the formula is already adjusted to be able to account for this, for that 1 month after. So that's where the person is supposed to start. But the issue here is that they don't actually start there. They start 4 months after. So you have to think about it like this. They're saying 4 months after as a whole, right? They're not even considering this 1 month. So we need to consider it. So if we're saying 4 months after, it means that here's where the loan was granted. It's 1, 2, 3, 4. So how many payments was actually delayed or missed? How many payments was missed? Because it's not really delayed, it just was missed as a whole. It was 3 payments that was missed. Now, there is a consequence for that. You miss 3 payments. What happens is the loan amount, how much you owed before, is not how much you're going to owe when you start paying. You're going to owe more, because what happens with that loan amount is you get charged interest on your loan. That's why when you take a loan from the bank, it is best to pay the loan as quickly as possible, because then you would pay less interest. However, people don't usually notice it because the loan time period will be like quite long. So you wouldn't even have noticed that you've paid the bank like so much money. In fact, before your loan is already done, like halfway through, you've already paid them their money back. And then now you're really just paying interest if you calculate what's going on. So we have to just account for this. Now, you see, this money is going to grow, but by how many months? It's going to grow by 3 months, because the formula is already adjusted so that you start paying 1 month later. So they can't charge you for that 1 month later, okay? Because that's supposed to happen normally already. They're only going to charge for that 3 months. That money is going to grow for an extra 3 months. So the first thing we need to do is take this money and actually grow it for 3 months. So that is A is equal to, and we're going to use the growth formula because we're trying to grow the money. So P bracket 1 plus I raised to the power of n. So let's find out what this is going to be. We'll take this amount and we're going to invest it for 3 months. So at that same interest, because it's in the same account. And so what we're going to have is 1 plus, and our interest is 0.09 over 12 raised to the power of 3. And I have to say times 12 because it's already in months. Okay, so let's go ahead and see what that gives us. Okay, so this is the amount that we get. A is equal to, it's quite long, so I'm going to take like 5 decimals just to be sure. I'll take 5 decimals. So that is 230,100 points, and I'll say 56367, and I think that should be fine, and it will not really affect the rounding. So what is owed right now is not this amount anymore. It's now this amount. Okay, that amount that we just got, that A amount, I'll just call it A. Okay, that's how much is owed now. And so that's going to be your present value. Okay, so that's what we had to consider. This is now the present value. Okay, so we're still using the present value formula. We have now accounted for the 3 months missed payments. So now that we have gone ahead and found out this amount, we can now find out how many payments, okay, in total, Lesibana is going to make to settle the loan. So let's go ahead and do that. So we're going to use the present value formula. Okay, so that's our present value is equal to, and the X amount, the monthly payment is 5,500, then 5,500, and then 1 minus 1 plus your interest. We have that, okay, 0.09 over 12 raised to the power of negative n, because that's what we don't have. N is the amount of payments, okay? So I'm going to leave n as it is like that because n is going to be in months. You notice that when we're putting this formula down, right, we usually write the years, like if it was 5 years, then we'll say times 12. Is to convert it into months. So I'm not going to do anything to that. I'm going to leave it in months because the months will tell us how many deposits were made, since these deposits are being made monthly. Okay, so I have that, and then close the bracket all over, and then it's going to be all over the interest that we have here. Okay, so we're just trying to find n. Let's see how we can do this. Because it's an exponent, there's a lot more we need to get rid of. So what I'm going to do is this. I'm going to go ahead and take 5,500 and divide it by this fraction. Okay, so let's divide that so that we can just get a number that we're going to put in front of the bracket. Okay, and I would rather leave this number as a fraction because as a decimal, you will lose some decimals and that will probably be a problem later on. So what I'm saying is this is an entire fraction, but I'm deciding to divide this by this so that I can just put that number in front of the bracket. And so that number is 2, and then how many zeros are those? Okay, it's like 5 zeros. So 1, 2, 3, 4, 5 all over 3. Now it's not a problem because I'm going to get rid of this very soon. It's just to hold on to that, like to get that together. Then we still have exactly what we had in the bracket. So I'm really just going to take that and rewrite it again. Remember, in this part, you just have to be really careful in financial maths. Just make sure not to miswrite anything. And then this, of course, I'll leave it the same. I'm trying to stay safe by keeping it at 5 decimals, just so that, nothing goes wrong. Okay, so this is what we have now. So at this point, what we can do is we're trying to get to the end. So since you want to get to this, what we can do is just go ahead and get rid of this number, because this number is the first thing that needs to leave so that you can get to the end. Okay, so how do you get rid of that number? Well, this number is being multiplied to this. So if you divide both sides by that number, you would get rid of it. So that means we should just take this and divide it by that number. Okay, so I'm going to do that. Okay, so this is what happens. You see, I took this number, and I divided it by that number over there because I'm dividing both sides. So here they cancel, and here, this is what we have, and I'm going to calculate what that is. So this is what we have on this side. Okay, I don't need a bracket there. Okay, so let's just see what this gives us. Okay, so the number I get as a fraction, it's really complicated. So as a decimal, it will be better to write. So always write it. If it's a simple fraction, you can just write it like that. If it's a fraction that is not complicated. So this is a decimal. I'm going to write a 0.3137734. Now I will just go ... and I'm not really going to continue with that. I will just use this button ANS. That button is going to be very important in financial math always. And we're going to say this is equal to, and we have this still, and 0.09 over 12 raised to the power of negative n. Okay, so here, do you notice that this is actually negative? Because it has the n is also negative, but I'm just going to take that over. And so when it comes over, it now becomes positive 1 plus 0.09 over 12 raised to the power of negative n. So there's no negative in front of the bracket anymore. Then we still have this 1 here, and I'm going to take this number over. So it's minus that number, 3137734, and it keeps going. And so how I'm going to calculate that on the calculator is, I know that this has been recorded in this button ANS. So I'm going to press AC, clear that, and I'm going to say 1 minus ANS because that's that number that was there. And this is what I get as a decimal. So rewrite this again, 1 plus 0.09 over 12 raised to the power of negative n is equal to, and we get 0.68626, and that just keeps going. Again, I know it's recorded in ANS, so I'll hold on to that. Now do you see where we are with this calculation? We are at a point where we have our exponent there, which is negative n, and we have a base and we have an answer. You have to just solve this. This is an exponential equation. So you need to use log because these are complex numbers. They're not normal numbers that we can use here. So our exponent is negative n. That is going to be our subject now. And we'll say is equal to log, and the base number is going to be whatever was carrying the exponent, which is this. So I'll rewrite that as the base, 1 plus 0.09 over 12. And then here, I'm going to write that number, which I'm going to just write it as ANS so that it just makes it easier. Okay, so when I write this down, I'm going to say n is equal to, and you can press equal to, so that you have your answer. You would have already pressed equal to get your answer. Mine is a bit different. Then just press AC, and then you're going to go ahead and go to the log function that you need here. Log, and put down your base, which is this number over here. So we're going to say 1 plus 0.09 over 12, right? You can put brackets around it if you just feel like, it should be more protected. So I'm going to put brackets around that. And then here, I'm going to go ahead and say ans, so that it doesn't cut out anything and it's more likely to give you the correct answer. Okay. So press SD because my calculator is, So we say negative 50.394. Okay. I just need the 2 decimals really. And it's negative, so you can just multiply both sides by -1 to make it positive. And now you know that positive n is equal to 50.39. Okay, so let's see what this means, right? Remember, we're just trying to find how many payments, was made to settle the loan. So you see that after we had considered the 3 months delayed payment, we finally got that N, which is the monthly deposits, is 50.39. So it means there needs to be 50.39 payments to settle this loan. But focus on their question. They want to know how many payments in total. 0.39 is not a payment. It's not a full payment yet. And that's the thing about it. Because it's not a complete payment, we cannot say, because we're just going to round down and say 50 payments. It can't be 50 payments. At 50 payments, you're not done paying this loan. There's still the 0.39 remaining. So because of that, the full amount of payment that you need to settle the loan would be 51 payments. So that's actually the answer here. It would be a total of 51 payments. Hi grade 12s and welcome to this video. So in this video, we're going to be covering question 7, which is the financial maths section of the November 2024 grade 12 paper 1 exam. Okay, so we have 7.1 and let's get into this paper. Okay, so 7.1 says, Mary's grandparents deposited 5,000 into a savings account on the day that she was born. The account pays interest at a rate of 6.8% per annum, compounded quarterly. And then they say calculate the accumulated amount in this account on Mary's 16th birthday. Okay, so looking at this, money is not being repeatedly deposited. It's one amount that gets deposited. Her grandparents deposit 5,000. So we know that this money is going to grow. So from this, because one amount is being deposited and then it grows, we can see that this is clearly just compound interest growth. That's really all it is, okay? And it's compounded quarterly. So let's just go ahead and put down the info. So I usually like to write the word PAIN, P-A-I-N, okay, for our values. And the principal amount, the amount you start off with, is the 5,000. That's how much gets deposited. And then the accumulated amount, as you can see, that's actually what we're looking for. Calculate the accumulated amount. So that is unknown. And then the interest. The interest is 0.068% per annum compounded quarterly. So you need to make sure that you make it quarterly interest that gets added really. So you're going to divide that by 4, really cutting it into 4 quarters so that it gains interest every quarter. And then lastly, N. Okay, so they said it's when she was born until when she is 16. So it's 16 years in total. But remember that this is compounded quarterly. So it's going to earn interest every quarter. So you need to say the 16 years times the 4 quarters that they are in every year. Each quarter is made of 3 months, but that's not really important here. Okay, so that's all we have to do. Substitute and then we get our answer. So our formula is the compound growth formula, which looks like this. And then we're just substituting. So A is equal to 5,000 and then 1 plus 0.068 over 4 raised to the power of 16 times 4. Let's punch that into the calculator and see how much will be in the account. Okay, and the total amount in the account will be 14,706 points. Round off to 2 decimal places, that will be 56 cents. Okay, so just remember it's just because it's when she was born, okay? It's not when she turned 1 or anything like that. It's when she was born, which we will see as T0, okay? She's not any years old. The baby is not any years old at this point. But when they turn 1, then 1 year has passed and 1 year's worth of interest is going to be added to that 5,000 Rand. And then 2 years worth all the way to 16 years, which would of course be on her 16th birthday. Okay, so that is it for that question. Moving on to the next question. Okay, we're on 7.2, and 7.2 says, after 4 years, the value of a printer was half of its original value. Now, I like to take notes as I read these questions. So they say that there's a printer, it has a value. So it starts off with something. That would be the P value, how much it starts off with. And then how much it ends off with would be how much it ended up being at the end of the day. So after 4 years, the value of a printer was half the original. So it means if the original was 2x, then the printer ends up being x, half of it. Okay. Then they say determine the rate at which the printer depreciated over this period. So they want us to find the interest. If the depreciation was calculated according to the straight line method. Okay, so we're just using straight line decay, or really just simple decay. That's what we're using here. Okay, so we know this, and they told us that it's after 4 years, so we also know what N is. So pain, we know what N is, and we're just trying to find the interest, but we need to also remember to express it as a rate, so as a percentage. Okay, so let's go. We're going to use straight line decay or simple decay, which is A is equal to P times 1 minus I times N. Okay, so our A value is X is equal to, you can really use any amount. You don't have to use X necessarily. If you like, you can start like, okay, maybe the printer cost 100 Rand and then ended up with 200 Rand. It's still fine. Okay, because it's technically still that same idea. So this is 2x, and then this is 1 minus, and your interest, we don't know what that is, and we know that this is 4. Okay, so we're just trying to make I the subject. What do we have to do first? Okay, we can get rid of the 2x, and it's fine in this case. You're allowed to divide technically by an x because the x represents an amount. It's not 0. The printer does not cost nothing Rand. Okay, so 2x on both sides, and therefore what happens here, the x cancels. You have an invisible 1 in front of that x, which gives you 1 over 2. Okay, with the 2 there is equal to, and we have 1 minus I times 4 is 4i. So we clearly just have to make that the subject so that we can get I. So why don't we take it over since it's already negative? So that is 4i now is equal to 1, and take the half over, minus a half. 1 minus a half is just a half, and we have 4i. Then we can get rid of the 4 by dividing both hand sides by 4, and therefore I is equal to a half divided by, that's 1 over 8. But then as a decimal, that is 0.125. Okay, you can use a calculator, but yes, 1 over 8 is 0.125. So that is the interest as a percentage. So we're going to have to tell them the rate, right? So this means that the rate is, multiply that by 100. So times 100, that's going to be 12.5%. Again, you can use a calculator. So the rate is 12.5% per annum on simple decay. Okay, so there. So that is it for 7.2, and we move on to 7.3. Okay, well, in 7.3, and 7.3 says, Tipo was granted a loan of 100,000 on the 1st of March 2022 at an interest rate of 13.5% per annum compounded monthly. Tipo agreed to repay the loan over 5 years in monthly installments of, okay, so they're already given us the monthly installments. They told us the loan amount. They told us the interest. They told us how long it was. So they're giving us everything here, but okay. And then they say starting on the 1st of April 2022. And the first question is, calculate the total interest that he will pay over the 5 years. Yeah, this question is something they don't really ask a lot, but it's there in textbooks. You will see how to actually find the answer to these questions. The total interest that the person actually ended up paying. Okay, so let's go ahead and just gather the information that they've given us here. So first of all, Tsepo was granted a loan of 100,000. So that is the loan amount that was granted. And this was on the 1st of March, so 2022. So we're going to say 1 March and I'll say 22. So I'll remember. And of course, this loan goes for a total of 5 years. So if it's from the 1st of March 2022, then the last date we'll have for this loan would be in, so 5 years time, 2027. Okay, so it should end on the 1st of March 2027. So I'm basing this on the amount of payments because if it's for 5 years, he has to pay 5 years and he's paying monthly installments. So times 12 months, he's going to have to pay 60 payments. It still has to be 60 payments, regardless of the fact that he needs to naturally start 1 month after, because that's how present value formula works. They get a loan and then they start paying the next month or the next quarter, depending on the compounding period that you have. So for him to actually pay the full 60 payments, he has to finish on the 1st of March 2027. And I always like to test this out. The reason I want to test it out now is because, you see, this is a case where they didn't actually ask us to find that X amount. They didn't ask us to find the monthly payments. They already gave us that. So we can actually check whether this is accurate or not. So you can easily do that by using your present value formula. Okay, so I'll put down the present value formula quickly. Okay, so you can see the formula. So we can actually find out whether this is actually, true, just to see. I don't know, I usually play around with the numbers just to understand what's going on and stuff. So what I mean by this is I'm going to put down these that I have here, right? I'm not going to put the present value amount, but I'm going to put down this amount of 2.3, right? And then everything else. And by the years, I'm going to actually put minus 60 because I know that he has to make 60 payments. And I want to see if it actually gives us the total loan amount. Okay, very close enough. Okay, so you see that's almost 100,000. It's obviously because of the roundings. So maybe if we found, 2 decimals at least, then it would be 100,000, but it would be like 999 and then it rounds up. So you see that, yeah, they did the calculation already for you here. They didn't tell you to go find it. Okay, so that's good to know. We have that. Now, the first question is really just calculate the total interest that he will pay over the 5 years. Okay, so for us to be able to see that, we're going to have to think about how much Tsepo is actually paying. Like how much is he going to take out of his pocket and actually pay every month? We know that he's paying 2,300. So 2,398 cents every month. But for how long does he pay this for? He pays this for a total of how much months? 60 months, because he pays it for 5 years, but 5 years times 12 months each, okay, each year. So that's going to be, this is how much he pays. And let me actually title it that. So he pays, first of all, this amount. And then we can find out exactly how much this is first. I should just say times 60, honestly. 60. Okay, so he pays exactly 138,058.80 cents. Okay, in total. But then now, how would we find out how much interest he paid? In other words, how much extra did he pay? Well, how much did he borrow? He borrowed 100,000. He ended up paying 138,000. So how much interest did he pay? We're going to have to subtract, find a difference. So say 138,058.80 minus the 100,000, because that's how much he borrowed. That's how much he paid. So that's going to be 38,058.80 cents. And that's the interest. Okay, moving on to the next question. Okay, we are now in 7.3.2, which is the last question for financial maths. And it finally says, Tsepo paid 22,398. Yeah, that looks familiar. Okay, which is his monthly installment and an additional 20,000 on the 1st of March 2024 into the loan account. He continues to pay the original monthly installments thereafter. Okay. How many months earlier will Tsepo repay the loan? Yeah. Okay. Yeah. So this is 7 marks. There's that question. That last question is always, a bit of a headache. Okay. Let's break this down. They said that he paid in total 22,398, and they're saying that this amount is his monthly installment. Okay, installment, it's one payment, right? And an additional 20,000 rand. Now we can actually break that up and see that it is true. Remember that the installment that he's paying every month is 2,398. If you take the 20,000 extra he decided to pay, to help his loan just finish quicker, and then you take the monthly installment that he paid, you see that it gives you that 22. So 2300.98, sorry. Right? You see that if you add that together, it will actually give you the total. Okay. So we can actually just look at this in the timeline and just understand what's going on here quickly, because, we need to find out how many months or how many years or months earlier he's going to finish paying off this loan. So we need the timeline. That's going to be a very important thing here. Okay, let's just look at the story quickly. First, he gets a loan, right? Naturally, you're supposed to start paying the loan 1 month later. But I can't just assume that. We need to actually just check whether they actually accepted that or not. They started by saying that Tsepo was granted a loan of 100,000, and then on the 1st of March, at an interest rate of that, compounded monthly, Tsepo agreed to repay the loan over 5 years in monthly installments of this starting on the 1st of April 2022. Okay, so we see 1st of April 2022, which is true. It's a month later because April, we're going to have March and then April, May. So 1st of April, that's when he starts paying like everybody else. Okay, 1 month later. Now, the thing is, with this question, they're saying that he pays 22,000. We can see where that came from, okay, which is his monthly installment and the additional this. But he pays this on the 1st of March 2024. This is 2 years later from here, okay, 1st of March 2024. This is where, so he pays his payment, great. He pays that payment, but then he also decides to pay 20K extra. Okay, so that's what happens. He makes his monthly deposit and 20K extra. And then he continues to pay the monthly installments, and then we need to find out how many months earlier is he going to finish this loan because of this extra 20K. The thing about this is we are now assuming that Tsepo has paid for all of these other installments. And then they just counted this as a very important point because this is the point where he makes a payment on his installment but adds 20K extra. So how do we find out how much left will he have to pay? Okay, since this was on the 1st of March 2024, how about we find out how much he owed at this point, right? If we can find out how much he owed, we know how much he owes. We can remove 20,000 from that because he's paid 20,000 extra. Okay. So how much is he going to owe after he has paid this payment? Okay. Let's see. How we can find out that is just to see how long this period was. This is a total of 5 years. He decides to add this 20K in the second year. So this is after 2 years. So if this is after 2 years, it means that he had how many years left to pay off this loan? He had 3 years left. So I want to find out how much he owes here. So to find out how much he owes here, we can use the present value formula because the present value formula actually helps you to find out how much you owe. Remember in the beginning where I put down the present value formula and I put down the numbers and I only didn't put an amount for the present value. And then by n, I put negative 60. What I was trying to do there is to find out how much he would have owed if he had 60 months left to pay off the loan, which is 5 years. That's really just trying to find out exactly how much he owes when he borrows the loan. It's really just trying to find out the loan amount. Okay. So that present value formula is important for helping you find out how much the person owes at different times. So what I'm trying to find out now is how much does he owe when he has only 3 years left to pay off the loan. So in the second year. And how we can find out, let me put down the present value formula first. Okay, so here all we'll do is substitute, but then we're leaving present value open because we want to find out how much he's going to owe at a specific period, okay, after a specific period. And then the X amount, we know how much he keeps paying every month. It's 2,398 cents. Then I is still the same. It's still the interest, which is that 13.5%, right? Compounded monthly, of course. So that is 0.135 over 12. And then for the N, that's the most important part. The N, this is how you look at it. Instead of, I know that we are at the second year, but we're not going to put 2 here. You see, this says negative N. The negative N specifically stands for the amount of payments you still have to pay. Okay, that's what the N stands for. So instead of putting 2, we're not going to put 2. We're going to say how much payments do we have left to pay after 2 years. You have how much years of payment? You have 3 years worth of payments. But of course, this is compounded monthly. So for N, we're going to specifically say 3 times 12, which is 36 more payments left. Okay, so I'm going to try and find out how much he owes at this point. Okay, let's go ahead and substitute. So present value is what we're trying to find. I'm going to say 2,300.98 cents and then 1 minus 1 plus 0.135 over 12 and then raised to the power of negative 36. Okay, 36 payments left to go. And then over 0.135 over 12. Okay, let's see how much he's going to owe after 2 years. Okay, and when I punch that in, I get exactly, I don't like to round off here, but let's just keep 4 decimals. We can't go wrong there. Okay, so 67804 points, and we'll say 9364. I'm keeping 4 decimals because this is not our final answer. Okay, so we know how much he owes after 2 years. Okay, this is when he decides to sort that 20K. Okay, put that 20K in here. Still have to find out how much earlier is he going to actually finish paying off this loan. So now we know how much he owes here. He owes them 67,000. But what happens at this point? He pays off 20,000. So we're going to remove that because on that day he goes to the bank and he pays them 20,000. So now the new amount he owes is going to be, we're going to say 67804 and then, same thing, then minus the 20,000 since he's paying them on that day, which is just going to be 47,804.9364. Okay, so that's how much he owes them right now. And now to find out how long, we need to first find out how long will it take him to pay off this money that he now owes. This is like a new amount. What we can do is, it's almost as if you're restarting this whole calculation, right? You're remembering that he's still going to pay this amount as the monthly installment, but now we're starting from here, right? And we're saying, how long is he going to have to pay off this loan if he's paying this amount? And this is now the loan amount we're going to use. That's how much he now owes. Okay, so let's see. All we're going to do there is we're trying to find that N. We're still using the present value formula because it's still a loan calculation. So with our present value, our new present value, the loan amount, the money that he owes right now is this 47,804.9364. And then the X amount is still the 2,398 cents, 98. And then the interest, of course, is still the same, but the N is what we're looking for. That's the only difference now. Okay, so let's go ahead and put this in the present value formula and find N. That's what we're trying to do. Okay, so that is 47,804.9364 because I don't want it to round off too much. And 2300.98, and then 1 minus 1 plus. Now that I is still the same thing over 12 raised to the power of negative n. Now I'm not going to multiply that by 12, nothing like that, because I want to find out how much months before I can even try to maybe convert into years. Okay, they say how much months earlier. That's the question. I see that now. Okay. So we actually have to tell them in months. So let's leave that as negative n and don't multiply by 12 because you don't want to convert it to years or anything like that. And then all over the interest that you still have. Okay, yeah, numbers. Okay, so what I'm going to do is I'm just going to find the stuff that I just want to be put together. For example, this one, I don't like the way this looks right now. So I'm going to actually just find out what 1 plus 0.135 over 12 is on the calculator as a fraction, because it's easier like that. And so keep in mind that it's 809 over 800. That's what we have here, right? That's 809 over 800. And then now we can start working on dividing where we need to. So this is an equation and you're just trying to solve for the exponent of n. What you can do is, well, most people usually just multiply both sides by that. But what I do is I try to divide these two together so I can get them to be a single number. So this divided by this first. And when I do that, I get this number, right, with 5 recurring. But then what you can do is remember to use the number ones. It's still going to be fine. So I'll still write 204,531.555 because that's actually what happens. So let's just leave it as 3 5s. And then we still have this at the end, which nothing happened to. There's the reason I'm holding on to the calculator like that and not really putting anything yet is because I don't want to round off and I don't want to have to remember numbers. So long, what we're just going to do is, here's why I wrote this here. I'm going to just rewrite what we have left. Remember, there's no denominator anymore. It's just this number and everything in the bracket. So that's 1 minus, and now this we know is 809 over 800 raised to the power of negative n. And that's what we're looking for. Okay, so like that, and that's all we have there. And now do you see that in order to get closer to the n, you're going to have to get rid of this number. So to get rid of that number, it's been multiplied, so you must divide both hand sides by that number. So ultimately what we're doing is we're dividing this by this number. Here it would cancel because you're dividing by the same thing. But here you just have to say 478 that over this number. And that's why I kept that on the calculator. But you can use the button ans. Here's how I'll do that. So on your calculator, you can press AC because the answer would be recorded. On mine, I kind of have to press equal to first. And then I can say that 47804.9364. And then I can say divided by uns. And then it's actually going to give me the number that I'm looking for. Okay, so this is what we get so long. So make sure you keep using that uns button. It's going to be very helpful. Okay, so the calculation here would have just been the 47804.9364. And then, of course, we would have just said divided by that number that we had. Okay, like that. And then we would still have everything here, okay, which is equal to, and then we have 1 minus 809 over 800 raised to the power of negative n. Okay, so that's what we have there. And now we can, of course, write the answer that we got from dividing these two together, which is 0.2372, and this keeps going. So not rounding off yet. So I have 1.809 over 800 raised to the power of negative n. Okay, so at this point, we're just really trying to, the brackets are gone. I don't know why I'm writing them. So those are gone. And do you see that this is negative? Okay, it has a negative in front of it. Why don't you just make it positive by taking it over? So now it is positive 809 over 800 raised to the power of, that is still a negative n. Taking it over doesn't make it positive because it's an exponent. And then here you still have the 1, and then we're taking that answer over. So minus 0.2372 keeps going. So on your calculator, to get that, you can press AC because that is already recorded. I'll just press equal to first, and then I'll say 1 minus uns. And that's going to give me my number there. Okay, so 1 minus aunt is 0.7662, and I'm not rounding again. And we still have 809 over 800. You see here, it's really just the calculation and being careful with that. Okay, and we have that now. And now we can finally solve for the exponent, which is currently a negative n. So negative n is equal to, and we're going to use log. So log, and our base is 809 over 800. And our answer is this here. So here's the thing. We're not going to use this because it's going to round off. We're going to use that button ans again. So you can press AC on your calculator. I press equal to first. Then I'll say log with a base and say 809 over 800. And in place of my bracket, then you're going to say ans. Okay. And look at what it gives you. Negative n is equal to negative 23.79679, right? And of course, you can just multiply both sides by -1. And so positive n is equal to 23.7967. Okay, let's talk about this now. The question that we're trying to find, first of all, we found out how much he owed after the 20,000 was paid. And then we were trying to find out how much payments must he make to finish this loan that he now owes. And we got 23 point this amount. Now remember, the payments are of 2,389.98 cents. I don't know why I keep mixing that around. Okay, so this is the payments that he keeps making. So you have to now consider this. The question, right, is how many months, this is the question, how many months earlier will Tsepo repay the loan? If you're thinking about how many months earlier he has to pay off the loan, we need to find out how much months is it going to take him to pay off this amount. We got 23.79 that. If he only pays for 23 months, he's not done, because it means he's made 23 payments of this amount. He still has the 0.796 to go. Now that payment is going to be an amount less than this, but the point is still that the loan is not paid off. So we're going to have to round off to 24. Okay, so n here is going to be 24 payments that he's going to make. I hope you guys understood that part. 24 payments must be made to complete the loan. Okay, not just about paying that amount. 23 payments sure of 2,300 and that, but 24 payments to complete the loan. Okay, so now that we know he has 24 payments and we know when all of this happens, it happened here when he decided to pay 20K extra. So he probably went to the bank, was like, okay, I've been paying you guys and here's my payment for today, but I'm going to pay 20K extra. Can you guys tell me how much payments I need to make to finish this loan? Okay, so how we would look at that is he's paid for this month already. Now he has 24 more months to go. So after this, we're going to have to count 24 months from here. Okay, you can calculate that however you want to. You can like one by one count the months, 24 months, and find out. But from the 1st of March, if we start counting, right, 1, 2, 3, and we count till 24, you're going to end up at the 1st of March 2026, because that's exactly 2 years. So from the 1st of March to the 1st of March 2026. So that's a period of 2 years, meaning he's done paying at this point. So how early does he pay off this loan? You see that between the 1st of March 2026 and 2027, that is just 1 year, which is exactly 12 months. Okay, so there. He's going to pay this loan 12 months earlier. Okay, so that is the final answer.